the best path? So we know I is more preferred to question mark. So if I change this in the question mark, then automatically I will preferred, and I is what automatically make as a best path. Correct? Right or wrong? Okay. Right now I can receive both the side, that is I and then I, right? But if I'll change this one, let's say if I am changing this in the question mark and this is I, so again this will be preferred and automatically this route will act as a best path. Correct?
Yeah.
Okay, so let's discuss here like how to use this origin code. Okay, how to use this origin code attribute to make any path is the best. Okay. Now, how to use this, like this origin code? I want to add this origin code where? I want to add this origin code on 50.1 side, right? 50.1 side, it means here, right? So let's go on R1, sorry, R4, and then say what access list 10 permit host 6.6.6.6 done. Okay. After that, we need to create a route map. I'll say route map. Let's say what? Origin, origin code, and then say what? Enter. And then say what? Match IP address 10. And then set here what? Set origin. See, here we have two origin. It will be show me IGP. IGP is our local IGP. And incomplete. What is incomplete? This is what? This is the question mark. The incomplete is what? Question mark. So I want to say here what? Incomplete. And then say exit. Exactly same here. Permit and a higher secrets number, that is 20. Exit. Now we need to add this. I want to add this what origin code where? I want to add this origin code. We need to check it again to show IPGP. We need to add this because I want to change I is more preferred. Okay, I want to add in 50.1. So on R here, router BGP, and then say what? 200 and then say neighbor. Neighbor is what? It means neighbor is what? 50.1. And then say what? Route map. And then say what? What is the route map name? Origin code. Origin code, and then say what? Inbound. And on which interface? F0 by 0. Or and then say enter. Clear. Do clear IPBGP. Start and then say stop. So let's go on R5. Now if I'll show you, do clear IPBGP, start and then say soft. And now if I'll show do show IPBGP, BGP. Now it will be show me, they don't show me that path. Why? Okay, this is R5. I'm sorry. We need to check on R4. Do show IPBGP. See, now the path is best via 40.1. Why? Because this route I can receive from where? Question mark. It means this route I can receive from distributed route. Okay. So which is the preferred? I is a more preferred. So that's why 40.1 is what? More preferred. Clear now? Okay. Having doubt here? Yes, guys, have any doubts? So please tell me here.
So basically, what is the definition of origin code? That it means it's the I and the question mark. I don't get it. What's the origin? What's the
Origin code is what this is. We can say the symbol. Okay. We
okay?
can say this is called what symbol. So by default, always it will be show me I. But if you want to make any path is the best, so IE is more preferred to question mark. I is
Okay.
more preferred to question mark. Let's
Okay.
say right now, okay. Let's say which path is best. Again, I can remove. Again, I can remove here everything. Okay, wait.
I want to check the commands to change to incomplete.
Yeah, wait. I'll show the commands. What are the commands? Do show run 5 section access list. Route map. Router BGP. So these are the command. This is first access list command, and then what? This is the route map, and
Okay.
this route
One
map I
second.
can add with this neighbor.
Second. The I stands for what was it? The question was incomplete. The I stand for what? Forgot the name.
IGP. See, there are two origin code. I it means IGP, local IGP. Incomplete it means that is your question mark, redistributed route. What it means? Question mark it means what? That is your redistributed route. Okay. Done. You write these commands. Done. Can we move on the next topic?
Go ahead.
Yeah. Perfect. So now origin code, right?
Man.
Origin code is done. Now, now here we have what? Med. What is med? Med. Med is nothing. Med is what? Med is a metric. Okay, I can explain you here. Let's go on R1. Sorry. Let's go on R6 router. And now I'll show you do show IP BGP. No, there is no any med right now. Okay, I can explain you. I'll make a new topology. Then I'll explain you. See, let's say we have routers R1, okay, R2, R3, R4. In between R1, R2, the metric is what? EIGRP metric. Let's say 10. EIGRP 10, right? And this 10 is what? This is what metric, let's say. So in between R1, R2, the metric is what? 10. In between R2, R3, the metric is what? 10. Here we have a route that is 1.1.1.1/32, correct? And here I'm using what? EIGRP. Here I'm using what? BGP, correct? Okay. So in this time, what happened? Let's say we need to perform a redistribution here from EIGRP to BGP, correct? Now, yes, this R4 router, after the distribution, what happening? This R4 router will receive what? 1.1.1.1 route. Okay. 10 plus 10, that is what? 20. It means in EIGRP, it will be show me the metric is what? Metric is what? 20. But when this route is redistributed in the BGP, so this metric is also called what? Med here. What we call med. So in BGP, med it will be show me here 20. It means whenever if any route is redistributed from any routing protocol to the BGP, so that metric is called med in the BGP, right? Yes or no? So med is what? Med is a metric of IGP protocol actually. Okay.
So MED is a metric from IBGP to BGP protocol.
No. See, med is a metric of IGP protocol.
Okay.
IGP.
In IGP, yes, it means EIGRP, RIP, EIGRP, OSPF. So what happened here in this time? Here, okay, let's say right now I'm not performing any redistribution, correct? I'm not performing a redistribution. So right now, what happened? R3 router will receive 1.1.1.1 route with metric what? 20. So R3 router will install this route in the routing table like this. But R4 router don't receive the route right now. Okay. So what we need to do, we need to perform a redistribution. So let's go on R3 and perform a redistribution. Okay. Now after performing a redistribution, R4, here I'm using what? BGP as well. R4 router will receive 1.1.1.1 route with med. Med is what? 20. It means IGP protocol metric is called med in the BGP. Okay.
Okay.
Yes. It means whenever if you are redistribute any routing protocol into the BGP, so that metric is called med, we can say. That's it. I hope this is clear to you now. And lower med is the best. Lower med is the best.
Lower med is the best.
Yes.
The lower the preference is.
Yes. It means lower med is preferable. Okay. Now the next is what? Can you read this line? 8th is what? IBGP and EBGP. It means internal and external. So let's take an example. If we have a topology like this, R1, R2, R3. On R1, I'm using 100. On R2, I'm using what? 100. On R3, I'm using what? 200. Correct? Now, R1 router is also having a route 1.1.1.1/32. R3 router is also having 1.1.1.1/32. Correct? Now, this R2 router will receive 1.1.1.1 route here as well, and 1.1.1.1 route here as well, correct? But this route, this neighborship type is what? IBGP, and this neighborship type is what? ABGP, correct? So it means here it will be showing me the AD value is what? Tell me what AD value it will be showing me here and here. What AD value it will be show me here? Tell me.
The AD value in IBGP or BGP?
Yeah, this one. When I'll receive the route from here, then what AD value it will be show me here?
It's 200.
Okay, and when it will be received from here, then
It's 20 if it's EBGP.
it's a ABGP. It means that's why it will be show me what?
20.
20, right? So we know the lower is what best. So it means IBGP is a preferred. So it means if the condition is what? When I'm getting any route from, when I'm getting a same route from my IBGP neighbor and from my EBGP neighbor. So EBGP neighbor is a preferable. That's why here it is what external is preferable compared to internal, correct?
Mm-hmm.
Because of lower AD value, that's it. Okay.
So where do you see the MED? Where do you identify the MED inside the BGP? What does it show it?
Med, okay. Med normally they don't show you the med. Okay, normally they don't show you the med. How it will be show the med? Okay, I can explain you. Wait, I'll take 3 routers, then you can understand. Yeah. IP address is configured, right? Now on R7, what I can do, on R7, I also create a loopback, right? That is loopback 1, IP address 1.1.1.1, correct? And now on R7, I'm using what router EIGRP 0.0.0.0. Okay. Now on R8, I'm using what? Router EIGRP 10, and then say what? 10.0. The neighborship is up. Wait for a second. Now, can you see here? R8 router will receive 1.1.1.1 route, right or wrong? Okay. In between R7, R8, I'm using which protocol? EIGRP, right? Okay. Yes, guys, this thing is clear. In between R7 and R8, I'm using EIGRP. Now, yes, this R8 router will receive 1.1.1.1 route from R7, right or wrong? Clear? Okay. Now, I'll configure a BGP in between R8 and R9, right? Now, let's go on R8. Router BGP say 100, and then say neighbor 20.2. Remote AS will be what? 100. And exactly same on R9. Router BGP say 100, neighbor 20.1. Remote AS will be what? 100. Wait for a second. Now, yes, the BGP neighborship is up, but right now R9 router don't receive this route, right or wrong? Yes, guys, tell me.
Did you publish the?
Hello.
Did you
Yeah,
publish
what I
the
can
IP?
do right now, here I'm using 10.1 IP, here I'm using 10.2, 20.1, 20.2, and on R7 we have a loopback that is 1.1.1.1. Here I'm using what EIGRP. Here I'm using what? BGP. So right now R9 router don't receive 1.1.1.1 route. Right or wrong?
But
See?
why not? What? Mission? Oh, okay, okay. Yeah. Okay.
Because
Let's
because
start first.
why it is not receiving? Because AIGRP is a different routing protocol and BGP is a different routing protocol. So what we need to
Oh,
do?
okay, okay. You need to do redistribution.
Yes. So let's do the redistribution. Okay. Now let's just to say router BGP 100 and then say redistribute EIGRP 10. Say metric is 5 and that's it. Now if I'll show you on R9. Oh, I'm sorry. I no need to do a redistribution on R9. I'm sorry. On R8, we need to do that. Let's go on R8 and then say what? Say what router BGP say 100, redistribute EIGRP 10, and then say metric will be 5. Say exit. That's it. Redistribution is done. Now if I'll show you on R9 router, the route, the BGP table do show IP BGP. So yes, it will be show me 1.1.1.1 route, and here it will be show me the metric will be what?
Oh, okay, 5. That's the med.
So this is called what? Med. Automatically it will be received.
1 second.
Actually, what
1 second.
happened?
Wait.
How
1
it will
second.
be calculating actually?
Oh no!
Actually,
Don't
this
take
is
the
the
picture.
EIGRP metric.
Sorry. Can you put back again the picture and so I can, have a reference? Just the command. Yeah, just
Yeah.
there. Perfect. Thanks. It's okay. You can take it off now.
Yeah. So
you can
it
change the
means this is
metric
what?
more.
Metric is what? This is like whenever actually what happened? R9 router don't receive the route. Let's say I'm not doing any redistribution right now. So R8 router will receive 1.1.1.1 route with metric what? 5.
Right.
But R9 router don't receive. After performing a redistribution, what happening? R9 router is also receiving 1.1.1.1 route. And this 5 is what? This 5 is what? That is metric in the EIGRP. But in the BGP, it will be show me here what? Med. Med is what? 5. Here it will be show me what? On R9 it will be show me the metric. Actually, this is med. Okay. If I say med or metric, so both are the same thing. Okay.
Okay.
Done? Yeah, that's it.
Got it.
Now, weight is done, local preference is done, self-advertisement is done, AS path is done, origin code is done, med is done, internal, external is also done, right? Obviously, like external is more preferred to internal. Now, after that, IGP cost to reach next hope self. next hop self, it is only next hop. IGP cost to reach next hop. It means what? Okay. What happened? Let's say here we have a router R1. R2. R3. And R4. In between R3, R4, the metric is what? 10. In between R1, R3, the metric is what? 10. In between R1, R2, the metric is what? 10. Correct? Now, R2 router having a route that is 1.1.1.1. R4 router is also having the same route that is 1.1.1.1. Correct? Right or wrong? Okay. Now what happening? Here I'm having IP address what 10.1. Here I'm having IP address what 10.2. Here I'm having 20.1, 20.2, 30.1, and then 30.2. Correct? Okay. Now in this time what happening? This R1 router will receive a route 1.1.1.1 with the next hop IP what 10.2. Okay. And exactly same. This R1 is also receiving 1.1.1.1. Next hop IP is what? 30.2. Correct? Okay. Now, whenever these all the things are tied, so the device will check what? IGP cost to reach next hop. It means the next hop IP address is what right now? Tell me. 10.2 here, and here the next hop IP address is what? Tell me. 30.2. Correct? So now from R1 to 10.2, the IGP cost is what? That is 10. Okay. And from R1 to 30.2, IGP cost is what?
10. 20, because you
So
have
which
the
is the
two.
lower?
You have the 10 and 10.
Obviously, this is the lower. So this path is automatically act as a best. It means now it will be checking the IGP cost. They don't check the BGP cost. No, they will check the IGP cost. IGP cost to reach next hop. It means this is the next hop IP. It means from R1 to next hop, what is the cost? The cost is what? 10. And from R1 to next hop, the next hop is what? 30.2. Total cost is what? 10 plus 10, that is 20. Okay. That's it. So this is called what? IGP cost to reach the next hop. The lower will be preferred again. The lower IGP cost. Okay. Yes, guys, doubt. If you have doubts, so yes, ask the question, please.
So this is the eBGP path over IBGP. I mean, this is the shortest IGP path to BGP next hop, right?
See. Actually, what happened? This is work in case of which? In which case? I think it will work in case of IBGP only. Give me a second. Yeah. Yes. What you are telling? What you are saying? Yes. Can you repeat again, please?
No, okay, this is the shortest this is the IGP shortest path to BGP next hop, right?
Yes, correct. It means this next hop is what? This is the BGP next hop. This next hop is what? This is the BGP next hop. But from R1 to this BGP next hop, the cost is what? The IGP cost, that is 10. And this is the BGP next hop IP, that is 30.2. So from R1 to 30.2 BGP, like this is the BGP next hop IP, but cost we are talking about the IGP. So that cost is what? That is 20. So that is what? 20.
Okay.
So lower is the preferred. Okay.
Okay.
Yes, absolutely.
So,
You are telling this exactly same. Yeah.
okay.
Yeah. So lower is preferred here also. IGP cost to reach next hop, the lower is also preferred here as well. Okay. Now, once these 9 things are tied, because first of all, the device will check what?
Next hop.
Next hop reachability. Then the device will check what?
Wait.
If the weight is tied, then the device will check
Local preference.
local preference. If the LP is tied, then the device will check self-advertisement. Self-advertisement is tied, then the device will check what? AS path. AS path is tied, then the device will check what? 6, it means origin code. Then it will check the MED. Then it will check the internal, external. Then it will check the IGP cost to reach next hop. After that, one more option is there. That is what? Oldest path. It means, and this, but here we have a condition. This oldest path we are using in case of EBGP. In case of EBGP. So it means what? Let's take an example. Here it is what? R1, R2, R3. One dot one dot one dot one slash 32. 1.1.1.1/32, correct? Now this R1 router will receive. So let's say here the AS is what? AS 100. Here the AS is what? 200. Here the AS is what? 300, correct? Now what happening? Now what happening? Once this R1 router will receive what? Like 1.1.1.1 via R2, and it will be also receiving the same route 1.1.1.1 via R3. Clear? But what happened? This 1.1.1.1 I can receive at which time? Let's say the timing will be what? See, the timing will be what? 1:32. And this route I can install at which time? 1:34. So which is the older? Tell me.
132.
32 is older or 31? Sorry, 34.
31. 32. It's older.
32 is older, right? So it means this path is what? Best. And let's say what happened after some time, what problem happening? This interface goes down. So right now this path is what? Best and valid, right or wrong? And this path, it will be show me only on what? Valid. This path is not the best. Okay. Now after some time what happened? Let's say this interface goes down. When this interface goes down, then this route I'm not receiving. So automatically this path will act as a best, right? And after that, after some time, again this interface will be up. Now the timer is what? Now the timer is 136. So this will be what now? This will be what?
The best.
Older.
Okay.
And now this will be a best path. Correct?
Keep those.
So it means older path is the best. Okay. After that, here we have what? After that, here we have what? Lower neighbor router ID. But this work in the IBGP. Okay. Now how? Lower neighbor router ID is what? Okay. Let's take an example. Here we have a router R1, R2, and then what? R3, correct? Let's say R2 router having a route that is 1.1.1.1/32. R3 router having a route that is 1.1.1.1/32, correct? This R1 will receive this 1.1.1.1 route via R2. 1.1.1.1 it will be received via R3, correct? Okay. Now, once it will be receiving, let's take an example. This R2 router having a router ID will be 20.20.20.20, correct? And this R3 router having a router ID will be what? 30.30.30.30, correct? Right or wrong? Now it means for this 111, the router ID will be what? 20.20.20.20. And for this 111, the router ID will be what? 30.30.30.30, correct? So which neighbor having a lower neighbor router ID? Tell me. R2
Is
having
it
a lower
20?
neighbor router ID, R3?
R2, because it's 20.20.20.20, no?
Yes, yes. So this path is act as what? And this is only valid, correct? Because lower neighbor router ID will become a best path always. Okay, clear?
Okay.
Okay. But what I can do now here, let's say here the IP address is 10.1 and here it is what? 10.2, 20.1 to 20.2. Now what happened? Let's say both the device having a same router ID. Now here also I am receiving what router ID is what? 20.20.20.20. Now the device will check what? Lower neighbor router ID. So this neighbor router ID will be also 20.20.20 and this is also what? 20.20. Now it is what? Tie. This is what?
So
Tell me.
both are best and valid, no?
No. Once it will be tie. Once it will be tie. So this is tie. Now the device will check the next option. That is what?
Okay.
That is what?
Got it.
Lower neighbor IP address. So now the neighbor IP address, this is what? 10.2 and this is what? 20.2. So which is the lower? 10.2 is the lower. So via this path, it will act as a what? Best, and this always it will be what? Valid only. Clear? So these are the 12 attributes. Wherever the first attribute is tie, like next hop is tie, then what happen? Whenever the next hop is tie, then the device will check what? Wait. Whenever the wait is tie, then the device will check what? Local preference. When the local preference is tie, so the device will check self-advertisement. Then what? AS path, origin code, MED, internal, external, IGP cost to reach next hop, oldest path, lower neighbor router ID, lower neighbor IP address. So these are the attributes that we are using in real-time network to make any path as a best. Okay. So guys, I hope this attributes is clear for you now.
Okay.
Guys, have any question here? I hope this is clear.
No, it's clear.
Okay. Perfect. So now this is clear. Now what are the remaining topics? These are the remaining topics, right? AS migration, BGP route dampering, conditional route advertisement, ORF default route propagation in the BGP. You know, I think you told me BGP default route, right? So yes, we will
Yes.
also discuss. I told you we will also discuss the BGP default route in BGP as well. Okay.
Yes.
But these topics we will discuss tomorrow.
Okay.
Okay, good.
Okay.
Because too much
Not now.
information for one day.
Yeah, we need to grab some of
Uh,
this information that we learned today. Too much.
Mm-hmm.
yes, because today is too much.
Mhm,
These all the
Mhm.
attributes is there.
exactly. The videos that you are recording right now, for how long are going to be in the system to be watched?
What you are saying? Can you repeat again?
The videos that you are recording, I see that now they are posted on the website. For how
Okay, so you
long?
don't have access to
No, I
to
have,
download the
but I want to
video.
know when is it going to expire? How many
It
months?
says February 2000. I mean August 2023.
Okay.
Yeah, so you can download those videos.
Okay, for 1 year, right?
Okay,
Yeah,
yeah, yeah.
Yeah.
almost 1 year.
You can download. I think you can also access to download those videos.
Okay, good.
Okay.
If you don't have access to download, so just to tell me, okay? You can check
Uh,
and you can tell me tomorrow. Don't worry, okay?
okay. I'll check today. Yeah.
Yeah. So if you don't have access to download, then what I can do, I can download those videos and I'll upload those videos on the drive. Then I'll share with you, okay? Then you can download it
Okay.
easily.
Okay.
But first of all, you can check from your side. You have power to download or not. If you can, then that is good. If you cannot, so just to tell me tomorrow, then I can upload all the videos on the drive and I'll share you a link. Okay.
Awesome.
Okay. Perfect.
Yes. And I also have some small PPTs of the BGP. Okay, some PPTs of the BGP. So that is also I'll share with you. Okay.
Okay.
Yeah. So okay. So for today, I think it's enough
Okay, yeah.
because everything is finished in the BGP here. Okay. Like
Sure.
today's.
I think in switches,
Mhm.
switches, and
Mhm.
also we do this in routers. For example, in MikroTik, you can also put the weight. For example, let's say that I have
No,
two.
you cannot put this attributes in the switches.
No, no, I
If that
understand. I
switch will
understand. I am just
if
explaining you
that
what I
switch will support the BGP. Uh-huh.
exactly. Yeah, exactly. I know. I'm just explaining you what I know about the weight.
Okay, okay, yeah. Hmm.
Usually, for example, in MikroTik, we have let's say that we have three different providers, ISPs, and
Mhm.
you can we
Mhm.
can configure, let's say, way number one, number two, number three. So it has number one has the
Okay.
preference. So if
Yes,
number
perfect.
one and two fails, then number three comes up, for example.
Yes, correct.
So that's more or less what I understand.
Yeah, that is fine. But uh, you told me, according to you, you told me your topologies look like this. Wait. Start my pen. Give me a second. Okay. So now what happening? Now you told me according to you, let's say we have three providers. ISP1, ISP2, and ISP3, right or wrong? And this is your company router.
Exactly.
So you are taking the 3 ISP connections.
Exactly.
And this ISP is also having a route. Let's say it's a 1.1.1.1.
Yeah, these are ISP.
And here it is also 1.1.
They connect you through the internet, basically.
Yeah. So like what happening right now, this R1 router will receive 1.1.1.1 route, 1.1.1.1 route, 1.1.1.1 route from 3 sides.
Exactly.
This is from ISP1, this is from ISP2, this is from ISP3, correct?
Exactly.
Okay. And you're telling me, like, let's say you are set the weight here 100.
Exactly.
And you are set here the weight, let's say 200, and here you are setting the weight 300, correct?
Yeah, you can play around with this. I mean, you can put 300 the first one or whatever you want. Exactly.
Yeah, sure. And so in this time, which is the best path right now, according to me and according to you, you told me this is the best path, right? Best
Exactly.
and valid.
Exactly.
And here it will be show me only the star, right or wrong?
Exactly.
Super. But okay, you know, like if I'll connect from the ISP, like this R1 router is connected with the ISP. So obviously the neighborship type is what, IBGP or EBGP?
Assuming that is EBGP.
Perfect. Assuming, and in real network as well, it's EBGP.
In
right?
real life,
Okay.
will be EBGP as well.
Yeah. In real life as well, it's EBGP. Perfect. Now the concern is what? If it is EBGP, so just to tell me in this time, where we are adding this weight attribute. My question is what? I can add this weight attribute on ISP side, or I can add this weight attribute on this router, like on R1 router.
It has to
Like
be
you told me for ISP1, I can put the weight will be what, 100, and on ISP2 you are putting the weight will be what, 200. On ISP3 we are putting the weight will be what, 300. So my question is what? Once you add the weight 100, so you need to put 100 on ISP1 here, or you need to put this 100 on R1 router. Where you need to put this?
This usually in the R1, I believe.
Why?
Because that's the one, that's where I have the control actually. That's my router.
Okay,
I don't have control. I have no control on the other one.
I have a question for you. Okay, I have a question for you. Let's say you are not putting weight here on R1. Let's say you are putting the weight on ISP1, that is 100. So what is the problem?
Oh, you mean as a hypothetical? I don't know.
Yeah, I know you told me what, if we need to set the 100 weight on R1, but let's say if someone put this weight on ISP 100, so there is any problem or not? Like what happened in this case?
It won't work. It has to be on the receiving router.
Okay, so it means my question is what? Let's say if you are putting 100 weight. So my question is what? Whenever this R1 router will receive a route 1.1.1.1, so what weight it will be show you here? It will be show me here 0, or it will be show me here 100.
0, 0, 0, 0.
Are you sure it is 0?
If you are configuring on the ISP1, yes.
Why?
Because it's like you said, it's not transferable from, like, it doesn't update the.
Yes, that is the correct point. Superb. It means always when you put the weight attribute, so we are not putting this weight attribute on sender interface. It means on ISP, right? So always we are putting this weight where? On R1, right?
Exactly.
Okay. And one more thing here.
Wait, where do you configure this part? Because I think you said yesterday that you don't configure this on the interface itself, right? Where do you configure it?
No. We are not configure this this attribute on interface. We are configuring this attribute inside the routing protocol.
Okay.
Okay. We are not configuring this attribute on interface. We are adding this attribute on inside the BGP protocol because these are the BGP attributes.
Understand.
Okay. Yes. Now one more thing here. It means if okay, right now the traffic is come, right? Right now this 1.1.1.1 route is what coming right now, right? And I can also receive 1.1.1.1 route from here. I can also receive 1.1.1 route from here. I can also receive 1.1.1.1 route from here, right or wrong? Okay. It means this is called what? Inbound influence. What we call? This is called what? Inbound influence. Because right now the traffic is in, right? So it means if someone asks a question, when we use weight attribute, so answer is what? If we want to manipulate inbound influence traffic, then we use what? Weight attribute. Clear? Yes or no?
Yes, sir.
Any doubt?
No.
It means let's say if you want to manipulate outgoing traffic, right? So we are not using on that case this weight attributes.
Oh, so
okay?
this one is only
On
inbound.
that case, yes, it is inbound, we can say. Yes, it means we can say if you want to filter or if you want to manipulate inbound traffic, right? Then we are using which attribute? Then we can use what? Weight attribute. Clear?
Oh, I thought that this will work on both. Okay.
Yes. Okay.
Oh, but let me ask you a question from your experience. What is the attribute that you use the most usually? What is it, like the AS
No.
path?
It's no. Actually, what happened? It's depend on your
Topology.
Topology or your company routes. Whenever the traffic is in, right? Because right now what I told you, when we use the weight attribute, because we have 12 attributes in the BGP. So the question is what? When we use the weight attribute. So weight attribute we are using when we manipulate inbound traffic. Okay. And if I'll talk about which one, local preference, LP. So LP basically we can manipulate outgoing traffic, outgoing influence, we can say.
And inbound too or not?
No, yeah. We can use this inbound and outbound both. Why? Because what happened? This LP is share inside the update.
Okay.
So
What about
if I putting this local preference here, so yes, it will be effect here as well. But in case of weight, when you put the weight here, so they don't affect here, right?
Okay. What about AS path? Is it inbound and outbound?
Yeah.
Or
AS path. Okay, again, this AS path we are using for EIGRP basically, right?
Exactly. That's what we need.
Sorry,
That's
not
what we
EIGRP,
need.
EBGP, because
Exactly.
AS path is what? When the AS is added in case of EBGP, right?
Exactly.
And AS path is also sent inside the update. So we can say AS path is also we can use to filter inbound and outbound traffic.
Okay, perfect.
Getting a point?
Mm-hmm. You don't have like a
But
do you have like a table that says which one is inbound, which one is outbound and inbound? You have something like that or not?
no, I don't have any table. I can explain you, and I write on the notepad. Okay, don't worry.
Okay.
So I hope this this is clear to you, correct?
Mm-hmm. Yeah.
Okay. Now I can also explain you this using the topology as well. Don't worry. Now I'll show you first of all on R4. How many loopbacks we have on R6? Two clear. IP BGP start. Okay. So let's go on R6 router. What I can do on R6, I'll say what router BGP say 100 and then say network. Advertise this prefix in the BGP. Say enter. Now if I'll show the BGP table, do show IP BGP. So yes, it will be showing me this 666 route in the routing table, correct? Now, so this R6 router will share this prefix to R1. Now, let's check on R1 as well. Like R1 router will receive this router not. So we need to check on R1 as well. So the command is to show IP BGP. So yes, I can receive this 666 route on R1 as well. Now what this R1 router will do? This R1 router will share this prefix to R2 and to R3, right?
Mm-hmm.
Okay. Now, if I'll show you on R2, so give me a second. So on R2, yes, it will be showing me this route as well. In the BGP table, do show IP. BGP, yes, 666 route. I can receive R2 is also receiving. Now I'll show you on R3. Sorry.
Guys, I will step out 2 minutes, okay?
Yeah, sure.
I'm back, okay?
Okay, I'm also back. Okay, so what I can explain you now, this R3 router is also receiving 6.6.6.6. Now I'll show you on the main router, that is R4. Okay, now on R4, if I'll show you do show IP BGP, say enter, so it will be show me this 6.6.6.6 route I can receive from 50.1, and I also receive this route from 40.1, correct? Okay, done. Guys, can you hear me?
Yes, yes, yes. I can hear you.
Okay, perfect. So first of all, I'll show you the weight lab. Okay, first of all, we will do the lab for weight. Okay, so I'll show you. I can, okay, right now, once this R4 router will receive the route, what? 6.6.6.6, and from here 6.6.6.6. So from here, the weight will be what? 0. From here, the weight will be what? 0. I'll show you. Can you see here?
Yes, 0.
Weight
Both.
is what? 0 and then 0. Perfect.
Both.
Now, yes. Now what happening? If the weight is 0, if the weight is 0, then in right now the route is best via 40.1. It means the route is best via R2, right or wrong? Here it will be show me only this route is what? Valid. It is not a best, right or wrong? Okay, perfect. Yeah. Now, what happening? Right now, via R2, this path is best, and I want to make path best via R3 as well. Via R3, okay? I don't want to make this path as a best via R2. I want to make this path as a best via R3.
Question there. Why right now the 40.1 is the best one, the best instead of the other one? What is the reason?
Okay, I can explain you. The first attribute is what?
Next hop reachability.
Next hop reachability. And right now, inside the routing table, the next hop is what? 50.1. So first of all, we need to check I'm able to reach or not.
Yeah.
So yes, I'm able to communicate. And now let's check 40.2. 40.1. I'm able to reach. It means both. It means next hop is reachable from both the side. It means this attribute is what? Tie. Correct?
Mm-hmm.
Okay. Now the device will check the second one. That is what?
Wait.
Wait.
Wait, we know that both are in serial. So
yes. Now we know the weight is what? That is
0, 0.
0. Okay. This is 0. Now this weight is also tie. Correct?
Exactly.
This weight is also tie. Mm-hmm. Now the device will check the third attribute. That is what? Yes. Now if I'll show you, can you tell me the local preferences? What that is? Blank. It means 0, 0. Correct?
Yes, blank.
Okay. Now the device will check what? The route is set self-advertised or not. So no, it is not self-advertised because it will be show me the next hop IP. If it will be show me 0, 0, 0, then it is a self-advertised. So okay, this is also tie. Now the device will check what? AS path, and less AS path is best, right? We know less AS path is best. So right now, from here also it will be received 2 AS, and from here also it will be received 2 AS, right or wrong?
Mm-hmm. Yeah.
Okay, so this is also what? Tie. Now the device will check what? Origin code. You know, yesterday I told you there are 2 origin code, I and then question mark, and I is more preferable, right? But right now it will be receiving from both the side I. It means this is also what? Tie, right? Origin code is tie. Now the device will check what med. Okay, like what is the metric here? So right now the metric is also what? There is nothing any metric. So the metric is also 0, 0. It means okay. It means the metric is also tie. Now the device will check what? Internal or external. Like I can receive this route internal or external. So right now I can receive this route. I can receive this route external. Okay. It means from here as well I can receive the AD value 120. Sorry. From here as well, I can receive the AD value, what, tell me? 20. And from here as well, I can receive the AD value 20 because this is what? eBGP neighborship, right?
Wait, let me see. Let me see the R2. No, I know the R3. The one on the right because I cannot see the router. Oh, the R4.
See, this
okay,
is what
R4.
R3 is what 400, R2 is what 300, and R4 is what 200, right? So it means that is my eBGP neighborship, correct?
eBGP, exactly.
Yes. So if it is eBGP, then both the route I can receive from external. It means both the route I can receive from both the side. The AD value will be what? 20, right? It means this is also what? tie, right? Okay.
Exactly.
Now the device will check what? IGP cost to next, IGP cost to reach next hop self. So it means, okay, tell me the next hop is what right now? The next hop is what? That is, here it is what? 50.1, here it is 40.1, correct?
Mm-hmm.
This is 40.1 and this is what? 50.1, correct? So from here to here and from here to here, the cost will be, again, it will be same. Whatever the cost is there, that doesn't matter. But in between, like gap is what? In one router gap only in between R2 and R4 and R4 and R5. Sorry, R4 and R3. It means, let's take an example. Here the cost is what? 10. So here is also cost is 10. It means the cost is also tie. Getting a point?
Mm-hmm.
IGP cost is also tie. Now, I told you, whenever these 9 things is tie, now the device will check what? Oldest path. And this oldest path, it will be checked basis of, in which case it will be checking in case of eBGP. So actually what happened? Why it will be show me this path is the best? Because I think this path is older than this path. Let's do one thing. What I can do, I can shut down this interface, this 40.1. Okay. Right now, which path is best? Tell me. Yes.
40.1, right?
Okay. No, my question is what? Via R2 is the best path or via R3 is the best path?
Mm-hmm.
Tell me the answer. Via R3 is the best path or via R2 is the best path?
No idea. That's why I asked you before.
No. See. Yes. See, no problem. Here it will be show you best, right or wrong?
Exactly.
So it means this is what? 40.1. And where is the 40.1? Here it is the 40.1. It means via R2 is the best part, right?
Yeah.
Yes or no?
Yes.
Okay, perfect. Now, what happened? Why this is the best path? I think this route, it will be received at which time? 130. And this route, it will be received from here, it will be received, let's say, 132. So which is the older? This will be the older, right?
Where do you see
That's
this?
why this path is what? Best.
Where in the configuration you see this? This number, 130, 132.
No, it's just example.
Okay, but if you want to check
it is
it
just
on the
example.
router, but if you want to check on the router, how do you know that? How do you check this?
Okay, if you want to check, so okay, give me a second. To show IP BGP summary. Which is the best path? This will be the best path, correct?
Mm-hmm. Yeah.
So this will be a best. So can you tell me which is the older? Older is which one? 40.1 or 50.1?
40, because actually I'm just reading at the message.
It is yes, it is 40.1. 40.1 is older, right?
Well,
right now 40. Yes, right now the
but how do you
40.1
know
is
that?
older. That's why.
But it's not older because it's 1324, right? Older is the other one. It's 1 second difference.
No. 30.24 is the older. How? Okay. Let's take an example. This is the router. So from here, I can receive the route. $13.24 ego, and from here I can receive 13.23 ego. So this will be the older.
Okay.
You sure about that? I mean,
I
isn't
think
it?
it's the other way around.
Yeah, I think it's.
Let me check.
13,
Wait.
older, I think. Also.
Yeah, 1324 should be newer. 1323 is like 1 second difference.
Unless unless that means it's 13 minutes and 24 seconds. Then that's true. Then 1324 it's older. Because the session is up 13 minutes.
You're right.
Seconds.
Yes, the session is up in this time.
Yeah,
Oh no, yeah, you're right. So it's newer. So the 40.1 is newer, right?
exactly.
Okay, yes, it's correct then.
Okay, so that's why it will be show me this route is what? This route is what older. That's why do show IP, BGP. That's why this route is what best. Now what I can do? Okay, I can do one thing here. So this route from here I can receive what? I'll check. So from here, like 40.1, it will be receiving what? 13.13.24. And here it is 13.23. 13.23, correct? Okay. So what I can do? This route is older. That's why this is what? Valid and best route. And that's why this is all only on valid route. This is not a best route, right or wrong? This thing is clear?
Yeah.
Okay. Now let's say what I can do. I want to make this path as a best. So now what I can do one thing just to shut down this port. Okay, shut down this port, and after some time again just to up this port. Now, okay, so now again if you are up this port, so the older will be this one automatically, right or wrong?
Right.
Yep, it's supposed to be.
So automatically this path will act as a best, and now here it will be show me once the port is up, then it will be show me what? Only star.
Yep.
Okay, so let's do the practically this thing. So right now, which is the best path right now? Do show IP BGP. So the best is what? Via 40.2. Now let's do one thing. R4 interface F0/0. I'm saying shut down. Okay, and then say what? Shut down. And then say what? No shut. Wait for a second now. I'll say shut down first of all. And then say what? No shut. Wait for a second. The BGP neighborship is up. It will take some time. Do show. Yeah, now the neighborship is up. Now again, we need to check. Do show IP BGP summary. So this will be an older one, right or wrong now? Right, this will be older one, and this is the newer one. So now if I'll show you do show IP BGP, so it will be showing me which path is best now.
Yeah, right. The 50.
Right, and now again, let's say I want to make this path as the best. So what do we need to do?
Clear.
Tell me. Let's say I want to make this path as the best via 40.1. So what we need to do now? Tell me the solution.
Let me see something. We should clear the session, right? Again, on the other.
No.
Right
now,
you want to make the 40.1 again, the preferred?
Yeah, yes, I want to make again preferred is 40.1. So what we need to do?
simply shut down the 50.1 connection, then
Perfect. That is the correct answer. We need to go on interface F1 by 0 and then say shut down. Wait for a second and then again say what? No shut. Now wait for a neighborship. Do show IP BGP. Wait for a second. Yeah. Can you see here? And now if I'll show the timer, do show IP BGP summary. So see, this will be older. Sorry, this will be older, right?
exactly.
And older is the best path, right?
Yep, the older the best.
Yeah. So this will be older. It will be having like 2 minutes, and this is only the 34 seconds. So that's why this will be older, right? That's why this path is the best. Done. If this is also time, which one? If this is also time, but this will work only on what? In case of eBGP. Let's take an example. Here the neighborship type is what? eBGP. So this attribute is not working. Then it will be check what?
Router ID.
Lower neighbor router ID. And in case of IBGP, sometimes this lower neighbor router ID is also typed. After that, the device will check what? Lower neighbor IP address. Okay.
All right.
Okay. Now what I can explain you right now. On R4, let's go on R4. Right now, do show IPBGP. Okay, now right now the path is best via where? The path is best via 40.1. And right now I want to make this path via 50.1. So guys, tell me now, okay, I'm not doing the lab. I'm only entering the command. You guys told me how we can make this path 50.1 best using the wait attribute, and where we need to put that command, on which router, inbound, outbound, whatever, everything you can tell me.
Well, you said this is should be on the routing protocol, right? Not in the...
No, what happening right now, this R4 router will receive 666 route. The route is best via 40.1. And now what I want to make this path as a best via 50.1. And
using the wait.
This task we can achieve using a wait attribute. So what is the command and where we need to put this attribute on R2, on R3, on R4, on R1, in which router? Yeah.
I believe it should be in R4.
No, just to confirm this thing. On R4 or where?
In the...
When we put on R2, so what is the problem?
The thing is, because I am always thinking like I am the, like R4 is in our case, for example, we are the ISPs, and R2 and R3 are ISPs that we're buying services from. So that's why I'm telling you to use the R4, because we need to make sure that all the configuration is through, because in our case, in our scenario, R4 is the one that we have control. No,
let's say you have also control of R2 and R3.
Yeah, but that is not in our case in the real life.
No. This is also a real network. Let's say this router is also your, and you can also have access, and you can also have to do any configuration on R4, on R2, and on R3. And now what I want to make this path as a best. So can we implement this wait attribute on R2 or on R3, or where we are implementing on R4, R2, R3? Yeah.
Should be in R2, for example.
R2.
Well, wait, but you say that it will change to 0, right? it doesn't matter.
Tell me again. Yeah.
Even if you change the default, when R4 receives the update, it will get a 0 too, right or not?
Yes, it means there is no any change in the attribute. When you are implementing this attribute on R2, then they don't affect on R4. So it means we don't implement this wait attribute on these routers.
Yeah, that's what I thought. Yeah.
Yeah. So that's why I'm asking to you, like you told me, yeah, this is the reason actually. I'm not putting this wait attribute on R2 and on R3, because when you put on R2 and on R3, then what happened? Then they don't affect on R4. So what we need to do, we need to put the wait attribute on R4, right?
Exactly.
Okay. Yeah. So how we need to put it? Okay, it's very simple.
I
Just
believe...
to say what router BGP. Say 200, and then say neighbor. I want to increase where I want to increase right now. It is best via 40.1. So I want to increase here on 50.1. So the next hope, the neighbor is what? 50.1. And then say wait is what?
Put 100, the other 101, right? No.
Yeah, whatever you can.
Well, what is the default? The 32,768, right?
What?
What
Tell
is
me.
the default weight?
What is the default weight? The default
Yeah.
weight will be what? 32768.
Okay.
But that weight it will be show me when we advertise any that weight it will be show me in self-advertised route only.
Okay.
Okay. Yeah. Now if I'll show do clear IP BGP start and then say soft. Now if I'll show you do show IP BGP. So yes, it will be show me the weight is what?
100.
And
this is the preferable route now.
Done. So it means as a network engineer, if you know the whole concept of weight, now I hope you know all the concept of weight, like how we can put this weight or where we are putting this weight. So you can like easily you can understand in let's say your boss is saying you need to do this task or you need to do this task. So as a network engineer, when you know all the concept, then you can wait, you can use any type of attribute. When you know all the attribute concept, then you can put any attribute on that case. Okay. So the first thing is what? Just to understand these things and just to learn these things, what? When we are using this attribute, when we are using this attribute, when we are using this one, and when we are using this one. So if you know all attribute feature, then you can automatically you can understand where we need to put this attribute or where we need to put this attribute, right? So I hope this is clear to like it is clear. Any doubt now?
No, much clear now.
Hector, this is clear for you?
Is he there?
No
Hector? Maybe he stepped out for a couple of minutes or something.
Yeah. No problem. Okay. Now what we need to do, the second one, that is what? Weight attribute is clear to you?
Yep.
Now let's discuss here what? Which one?
Local preference, right?
Yeah, local preference. So if I'll talk about the local preference, okay, now I'll show you, right? Let's go on R4 and let's remove first of all the things.
So let me ask you one more question. You say the weight it's only inbound traffic, right? But in this specific case that we consider right now, how the outbound traffic is going to work then? in
right
this
now the
scenario.
traffic is coming, right?
Mhm.
Right now the route is coming. So this is, we can say, the inbound traffic. Okay. Done.
Mhm.
How you can understand? How you can understand this is inbound or inbound, outbound? Right now you are receiving that route, right? And when you are putting this attribute on here, then that route is out from here. So it means that is our outbound traffic.
Yes,
So we are
inbound.
not putting this attribute here. We are not putting this attribute here. We are putting this attribute here. So it means we can say when we are using of this wait attribute, when the traffic is inbound, okay? Okay.
That's what you mean, that the of this when they incoming to the router.
Yes.
It's
Yes.
not
Yes.
that
Yes.
it's
Yes.
not that the traffic will go from R4. It's not that you have to configure two different things, for example,
Yes.
for inbound and outbound. Okay, I understand now.
Yes. Yes. Exactly. Exactly.
So this command basically works in inbound, basically.
Yes. Yes. Exactly.
Okay.
This wait attribute we are using in inbound.
Understand.
Okay. Now let's discuss here what? Which one?
The local preference.
Yes. Perfect. Now what is local preference? Okay. First of all, tell me something about the local preference. What do you understand about local preference? Yeah, yesterday.
Local preference basically worked only in IBGP, I think.
Uh-huh.
And what else? The default was 100, and it was
Okay.
self-advertised, I think.
Okay.
That's what I have in my notes. I have nothing else.
Okay. Can we use this local preference in case of eBGP?
No, I think no. When the error will share the update to... No, it will not add. It will not add the local preference on the EVPC.
Yes. We can use this local preference in case of IBGP, right? It
Exactly.
means we can say in IBGP, the device will, whenever the neighborship type is what IBGP, then yes, it will share this local preference, correct?
Exactly.
But when the neighborship type is what eBGP, so they don't share the local preference. Clear?
Yes.
Okay. Now, right now in our case, right now the neighborship type is what here? That is eBGP, right? So what I can do, first of all, I can explain you what. Sorry, in eBGP, right? Okay. Now, let's go on R4. Okay, can you tell me one thing here? Okay, first of all, we need to remove the line. Router BGP say 100. Okay. So can you tell me right now the path is best via R2 or via R3? Yes.
Hold on.
Right now this R4 router will receive the route 666 from here and here. So just to tell me this path is like this 666 route is best via R2 or via R3?
In this case.
Yes.
Well, right now the local preference is in 0, right? From what I see there, it's empty.
No. Just to check here, just to check this topology, just to check this configuration and check which route is best.
The first one, the R3.
Obviously, it means this route is best, and this is the preferable. It means this route is coming. This route is best via, sorry, via R3, right? Because 50.1 is what? R3. Here it is what? 50.1, correct? 50 network.
Yes.
Okay. Okay. So it means right now, this R4 will receive what? 6.6.6.6 via 50.1, 6.6.6.6, and it will be receiving via, sorry, here it will be receiving via 40.1, here it is 50.1. 40.1. And then what? 50.1. Clear?
Yeah.
And which is the best path right now?
Yeah, from R3.
This route is, yes, via R3. Now, and right now the neighborship type is what? Tell me in between R2, R4 and R4, R3, the neighborship type is what? Yes. EBGP, right?
Yes, because the AS are different on each one.
Yes. Okay. And right now, what I teach you, LP, it means local preference, right? Okay. So in case of LP, or we can say in case of local preference, what happening? Can you tell me this LP is carry in case of EBGP or not?
What do you mean? No, it should not work. It should not work.
No, right?
No.
Yes.
So you need to change
Perfect.
the AS on both, on R2 and R3.
Yes. And right now, yes. And right now here also I can receive the wait, sorry, that local preference is what? 0. And here also I can receive the local preference is what? That is 0. Correct?
Yes, sir.
And right now the path is best via where? Via R2 or via R3? And I want to make this path as a best via R2 actually. Okay. So what we need to do? We need to increase the local preference. Yes or no?
Yeah.
Once I increase the local preference.
First, you need to change the AS on R2 and R3 to be same as the R4, basically.
No. Let's say right now I'm using a EBGP. Okay. I'm not using IBGP. Okay. Yes, I'm using EBGP, and here the AS like right now the local preference is 0. So we need to change this in 100, right? Okay.
Yeah.
Question is what? See, my question is what? Let's say on R1 this interface on R1, let's say I'll go on R2 router, right? And I'm changing here for 6.6.6.6 route. The LP is what? That is 100. Okay, the LP is what? That is 100. So just to tell me, once this R4 router will receive the route 6.6.6.6, so the LP is what? What LP it will be show me? 100 or 0? Again, I'm repeating this point.
0.
On R2, I'm using what? What I can do on R2, I can increase the LP, that is 100, for which route? For 6.6.6.6. So once this R4 router will receive this 6.6.6.6 route, so the local preference here it will be show me 0 or 100 what?
Should be 0, right?
Why it is 0? Give me the reason.
Because you say that when it updates on the next one, it doesn't receive the update, right?
No, yes. Actually, what happened in case of this neighborship type is what EBGP, right? So in EBGP, if you are changing the LP here, so they
Okay.
don't carry the LP inside the update, right?
Exactly.
So that's why once this R4 will receive, so the LP will be what? 0, right?
Exactly.
Okay. So it means what happening? It means once I'll change the LP on this router, so it is not working. But okay, this thing is clear to you? Yes or no?
Clear.
Yes. Now let's say it means once I'll do the change here, so it is not working in case of EBGP, correct?
Mm-hmm.
Okay. Now let's say I'm doing a change on R4, right? I'm doing a change on R4 router. So let's go on R4. Router BGP say 200 say neighbor. .1 and then say what? Local preference. How to change a local preference? We need to create a basically for local preference what? A route map. So I'll say access list 10 permit and I want to permit which one? 6.6.6.6 and then say route map CCIE and then say what? Match IP address. What is the ACL name? That is 10. And what I can do? I want to change what? Set
The
local preference. And I'll say local preference will be what? 100 and then say exit.
And basically,
And
this will match the incoming from 666, which is R3.
yes, absolutely. Which is coming from not R3 only. R4 router will receive this 666 route from both the side.
Oh, okay.
Okay. So right now, just I'm saying what?
The only
666.
666. Exactly.
Yes. And CCIE. And then say what? With higher sequence number. Wait for a second. Again, what I can do? I can remove each and everything. I can remove the route map again. And okay, I can copy paste again the same. This is correct actually. Okay, that's it. So access list is done, route map is done. Now what we need to do? I'll say router BGP and then say what? Okay. Just to tell me, I have a question for you. Okay, I want to increase the local preference here 100, right? So from where I want to, I can increase the local preference via what I want. Like I want to add 100 local preference via R2 or via R3.
Okay, you have that is coming from R2 or R3. That's what you want to do.
Yes. My question is what? You want to add this local preference 100. So where you want to add this 100? Once you receive the route via R2, then you want to add 100, or once you receive the route via R3, then you want to add 100. Tell me.
I have no idea in this one.
Oh, see, it's very easy. See, I told you, you want to make this path as the best, right or wrong? Right now, this is the best path, correct?
At this moment, yes.
And
So
if you
you
want
need to set
to
it
make
up.
this
Or...
path as a best, obviously, let's say if you want to make this path as a best, then you need to add 100
366.
local preference on R2. Like once you receive the route via R2, then you need to add, right?
Mm-hmm.
So just to say here what neighbor, R2 is the neighbor. So R2 having the IP address is what 40.1. And I want to add a route map here. And what is the name of your route map? That is CCIE.
You specify the router from is coming from, which is R2 in this case.
Yes, I'm specify the neighbor. Like once I receive the route 66666 from neighbor 40.1, then you can add this local preference 100. Okay, say enter and then say exit. Wait for a second. Do clear IP BGP star soft. And now we need to check do show IP BGP. So can you see here?
Oh, okay. It's coming from, but still
Here the local preference is what? 100, but still the route is best.
Exactly why?
Via 50.1. It means in this case, what happen if you are using this local preference in case of EBGP. In case of EBGP. So they don't work actually. Okay, they don't work actually. Okay.
Okay.
Okay. Yes, the local preferences change. That is fine, but it is not working actually in case of EBGP. Correct?
Yeah. You're right.
It means in case of EBGP, if you are putting this local preference, this interface, then still it is not working. And if you are put this local preference, this interface, still that is not working. Yes, that local preferences change. That is fine, but it is not doing our task actually. Still, the route is best via the previous route. Okay. The local preference is higher. Higher is preferable or lower?
That's a good question. You mean if it's higher or lower?
Higher is preferable, but still it is not best
higher.
Because it is not work in case of EBGP, right?
So higher local preference is the best path.
Yes. This is higher right now. This is 0, but still it is not working because of the neighborship type is what that is? EBGP. Clear?
Clear.
Okay. Now let's change the AS now. Okay.
So now if you want to make it work with the local preference, you have to change the AS on both, on R2 and R3 to AS.
No, in this case, if you want to make this path as a best using the local preference, so you cannot do.
No, I know, but if you want to do a test right now, you can change the AS on the R2 and R3 and then test if the local preference works.
Yes, then it is working 100%.
Okay.
Okay, so it means if you want, in this case, right now this R4 router will receive 6.6.6.6 route via R2 and 6.6.6.6 via R3. And if you want to manipulate and you don't have power to access the R2 and R3, you have power only to manage this R4 router and perform the manipulation. So if you want to do a manipulation here, so we cannot use the LP here. We can use what?
Wait or anything else.
Wait here.
AS path or another.
Okay. Yeah. Now let's change the AS now. So let's go on R2. Now what I can do, R6 uses AS100. R1 is also uses what? AS100. R3, R2 uses what? AS200. R3 is also uses what? AS 200. Okay.
Exactly.
And R4 is also uses what?
200.
AS what? 200. And this R5 is also uses what? AS 200. Correct. Let's do the configuration now. Let's go on R2. And first of all, we need to remove the BGP. No router. BGP 100, 200, 300, 400. Let's go on R3 now. First of all, we need to check which AS is working here. BGP 400 is working. So just to say no router BGP. Say 400. And let's go on R4 as well. Say no router. Just to say no router BGP. And then say what? On R4, we need to say what? 200. This is also I'm saying what? Okay. So now everything is removed on these three routers. Now let's go on R2 router and then say router BGP. We need to use here the AS is what? 200 and then say neighbor 192.168.20.1. Remote AS will be what? 100 and then say neighbor. Okay, wait. Need to say no. We need to do one thing. We need to remove the BGP on R1 as well. No router BGP and then say 100. And again, we need to configure the BGP on R1. Okay, so just to say what? Router BGP and then say 100. And then say neighbor 192.168.10.1. Remote AS will be what? 100. And then say neighbor 192.168.20.2. Remote AS will be what? 200.
Wait.
And then say neighbor.
Wait. On the 10. Oh, okay. No, it's fine. 10.1. Okay, yes, 100.
Yeah. 30.2. And then say the remote AS will be what?
200.
Again, it is 200. Yes. And now let's go on R2. And first of all, we need to say what? Router BGP say 200 neighbor 20.1. Remote AS will be what? 100. And then say neighbor 40.2. Remote AS is what? 200. Perfect. And let's go on R3 as well. I'll say what? Router BGP on R3 router BGP 200, and then say neighbor 192.168.50.2 remote AS. Remote AS is what? On R3 50.2, remote AS is 200. Neighbor 30.1, remote AS is what? 100. Now let's go on R4. Router BGP, say 200. Neighbor 192.168.40.1, remote AS will be what? 200. Neighbor 192.168.50.1, the remote AS will be, let's say that is 200. Wait for a second. Wait for a neighborship. 40.1 is up. Let's wait for 50.1 neighborship. Yes, now it is up. And now let's go on here. Neighbor 60.2 remote AS. This is 200. Wait for this neighborship as well. We need to check on R5 as well. Show IP protocol. Okay, here I'm not using any BGP, so that certainly will show me the problem. So let's go on R5 and then say what neighbor 192.168.60.1. Remote AS will be what? 100. Sorry, not 100, it's 200. Say enter, wait for a second. Yes, the neighborship is up. Correct. Done. Any doubt at this point, anyone? Yes, do you have any doubt?
No. So far so good.
John, Hector, everything is going good? Okay, perfect. Now also the BGP table, do show IP BGP. So they don't show me the BGP table. Why? Okay, let's check on R1 first of all. It will be showing me the route in the BGP table or not. No. We need to check on R6 as well. Show IP BGP. Yes, here it will be show me. We need to check the neighborship. The neighborship is up or not. In between R2 show IP BGP summary. Okay, the BGP neighborship is what? Idle. We need to check first of all the configuration. Router BGP. On R1 as well, we need to check the configuration. Who should run 5 section router BGP, say enter. On R6, I'm saying my neighbor is okay. On R6, I'll create a neighborship using the loopback actually. So we need to remove this command here and then say neighbor. Sorry, 6.6.6.6. Remote AS will be 100. Update source loopback 1. Wait for a second. Yeah, now the neighborship is up. Now if I'll show you. Now the neighborship is up. Now if I'll show you on R1 the BGP table, so it will be show me the 666 route in the BGP table. Do show IP. So yes, it will be show me the 666 route. Okay. Guys, give me 5 minutes only. Okay.
Sure.
Yeah, I'm coming. Yes, I'm back.
I'm here.
Yeah. So now everything is going good. Like now I'll create an IBGP neighborship in between these routers. Okay. So let's go on R4 and I'll show you. I'll receive the route or not. Do show IP BGP. So yes, I can receive the route, but that route is not best in any side. Why? Because the next hop is not reachable. So what we need to do? We need to go on R2 router. Just to use a command neighbor 192.168.40.2 next hop self do clear IP BGP start soft. Same command we need to use on R3 neighbor 192.168.50.2 next hop self do clear IP BGP start soft. Done. Let's go on R4 now. Previously it will be show me these next hop. Now if I'll show you, so it will be show me the next. Yes. Now the next hop is this one, and now this path is best via 40.1. Clear? Any doubt?
Why you put the what was the command that you put on R2 and R3?
On R2 and R3, I'm putting a command next hop self.
Okay.
You know what this command will do? This command will change the next hop IP address.
Will change, you say?
Yes, will change. Actually, what happens? See, previously I can receive the next hop is what?
Yeah.
30.1, 20.1. Where is 30.1, 20.1? Here. This interface is having 20.1. This interface having 30.1. So previously R4 router will receive this R1 router next hop IPs, right? But now I'm using a command on R2 and R3. Please use this interface next hop IP. Now, once after using this command, now again if I'll check the neighbor, then it will be showing the next hop IP 50.1. It means where is 50.1 here and where is 40. Now the next is 40.1 and this is the 40.1. So it means after using the command on R2 and R3, what the router will do, that router will change the next hop IP. Clear?
Clear.
Yeah, perfect. Now right now the route is best via
40. So it will be
40.1. It means via R2 or R3. Tell me.
R2.
Perfect. Via R2. And now the local preference automatically it is what?
100.
100, right? Okay. So it means this is what tie and higher will be preferable. Now let's say I want to make this path as the best, right?
So change it to 101.
So what I can do? Yes. Right now I want to make this path as the best via R3. So via R3 it means right now this R4 router will receive this route from both the side, correct?
Exactly.
From both the side, and the path is best via 40.1. It means this is the best path. And this is only what valid. Now what I want to make this path as the best. Which one? This one, right?
Yeah, you need to change your local preference to
Yes. Right now here I can receive the local preference is what? 100. Here also I'm receiving the local preference is what? 100. Now the concern is what? What is the concern right now? I want to change the local preference higher on which side? We need to increase the local preference here. It means let's say if I add here again 100, or let's say if I'm adding here 200, let's say. Okay. Done. So now the concern is what? We are doing a change on R4 here, or we are doing a change on R3 here, where we need to do a change. So first of all, we can do the change on R3 and check the output. Okay.
Okay.
Okay. So let's go on R3 router. And we need to use what? First of all, let's go on R4. We need to check we have any access list. Yes, do show IP route map. Well, we need to check the route map is available or not. Do sure and pipe section. Route, if it is available, so we need to remove that. Yes, route map is there, so we need to remove it. And we need to remove the access list as well. Do sure and pipe section. List. And we need to remove from the BGP as well, this route map, router BGP. Yes, that is removed. Perfect. Everything is good now. Again, we need to check on R4. Do clear IP BGP start soft. I will show you on R4. Do show IP BGP. This route is best via where?
Yeah, the quality.
Yes. Okay, so let's go on R3 and do the change. Let's add 200. Okay, now on R3, I'm doing what? I'm changing here what?
200.
LP, that is 200. Okay, let's go on R3 and then say what router BGP. Say 200 and then say no. First of all, say exit. First of all, we need to make an access list. Access list 10 permit and then say what host 6.6.6.6. Say enter. Okay. And we need to create a route map now. Route map PCI and then say what deny. Sorry, we need to say permit. Say enter and then say what match IP address. The ACL we need to match, that is 10, and then say set local preference, that is what 200 and then say exit. Again we need to make the same ACL with higher sequence number, because by default once I'm using this command automatically it will be taking a sequence number what 10. So now I'll make one more ACL with higher sequence number, that is 20, and then say exit. Now say what router BGP, say 200, and we need to add this attribute here, right? This link. So the neighbor is what? We need to say neighbor. We are adding 192.168.50.2 and then say what route map. What is the name of route map?
CCIE.
And then say, okay, here we need to put what? Like outbound and inbound.
Outgoing.
Yes, here it is what outbound and then say enter. Wait for a second. Do clear IP BGP star and then say soft. Do show IP BGP. Do show IP BGP, say enter. Now if I'll show you on R4, so let's go on R4. Do show IP BGP. Can you see here?
Oh, 200. So in this case, when using eBGP, it will update and will receive the local preference, right?
Yes. It means.
I'm sorry, IBGP, no eBGP, IBGP.
Yes. It means you can add this. It means this local preferences work in outbound influence, right?
Exactly. So
correct. This is also working outbound influence. Now what I can do, see. Now I'm removing this all the things from here, and again we are putting on R4. Then we need to check the output. Okay. It is working or not? Yes, it is working on sending interface like here. Now I'm removing from here and I'm putting the same thing on R4. Then we need to check it is working or not. Okay.
Okay.
Yeah. So let's go on R3 now and then remove all the things. So just to do very simple, do show run pipe section router BGP. Sorry, it's BGO, not O, it's BGP. Everything is removed. Okay, now again, if I'll show you on R4, so previously it is best via here. Now again, if I'll show you do show IP, BGP. So now the local preference is what? Again, it is 100 and it will be best via 40.1 again. Correct?
Yep.
Right? Okay, perfect. Now we need to put these all the things on R4. So I'll make a ACL access list and then say 10 and then say permit host 6.6.6.6 route map. The name is what? CCIE permit match IP address. We are adding ACL and I'll say what I want to set the local preference. I'll say local preference is what? 200. Say exit. Again, it's CCI permit and higher sequence number. Say exit. Now say router BGP. Say 200 and I want to add this thing where for this neighbor, right? So I'll say what? Neighbor 192.168.50.1 and I'm adding what here? Route map. What is the name of route map? That is CCIE and the bound is what? That is
Yeah,
inbound.
in this case will be in. Exactly.
Yes, absolutely. Do clear IP BGP starts off. Now if I'll show you do show IP BGP, say enter. So can you see here?
There you go. Okay.
And this is also will make as a best part. It means when you are using this BGP, sorry, when you are using this
IBGP.
Local preference attribute. So this local preference attribute, first of all, it is work only on in IBGP. This is the first. AS migration. Now, let's say what happened. This is the ISP. Here we have ISP. So it's ISP 1. Okay, and this router is connected with ISP. This is the router. This router is also connected with one more switch. And the switches is connected with the PCs. Correct? So this is our scenario. Clear? This is the simple topology here. And right now, this ISP uses, just to do one thing. This ISP uses what? AS. Let's say this is 1000. Okay. And this company, this is our like small company. So our company also uses what? AS. Let's say 100. Correct. My company uses what? 100. Right? This thing is clear. So it means in between ISP and R1 router, the neighborship type is what? Tell me, IBGP or EBGP?
In this case, EBGP.
Okay. Now the neighborship type is what? Perfect. This is what? EBGP. Very simple. And let's say here the IP address is what? 99.1 and here the IP address is what? 99.2. So how I write the commands? Very simple. I write the command like this, like on ISP, I'm saying what? I'm writing a command what? I'm using a command what? Router BGP and AS number is what? That is 1000. So I'll say 1000 and then say what? Neighbor. Who is my neighbor? The neighbor is what? 99.2, right? And then say remote AS is what? Tell me. Yes, remote AS is what?
100.
Yes, it's 100. Perfect. Exactly same thing on R1. I'm saying what? I'm using a command what? Router.
BGP 100.
100. And then
Neighbor.
say what? Neighbor
99.1, remote as 1000.
Perfect. The remote AS will be what? That is 1000. Super. So this is the normal network. Right now we are using this normal network, right? But now what happening? Now what happening? In my company uses AS number what? 100. And now what I want to change this AS. I want to change this AS from AS 100 to AS 200, let's say, right? This thing is clear? Because let's say small company network. But now what happened? Now in my network, okay, I'm using more devices in my network. Switch 1, let's say, switch 3, like that. Okay. So that's why what I want. Now we need to change this AS number from 100 to 200. Clear? Okay.
Yeah.
Perfect. So what happening now? But let's say on R1, right now my AS number is what, 100, and I want to change this 100 into the 200. So if I want to do a change from 100 to 200, then we need to do a change on ISP end as well, correct?
Yeah, in this case, we will have to call the ISP to do the change. For
Yes,
example.
it means what happened? We need to do, and if I want to do a change, then we need to do on R1 router as well as on ISP router as well, correct? And we know we don't have any control of ISP routers, correct? This R1 router have control, only this R1 router. R1 router don't have control ISP router, correct? This thing is clear, yes or no?
Okay.
So it means if I want to change my AS from 100 to 200, then we need to do a change on R1 router as well as we need to do a change on ISP router. So this is a very hectic task for the network engineers because I have control only on the R1 router. I don't have any control to ISP router. So what we need to do, we need to call to the ISP and say to request and give some money and just to say, please change my this command here 200, correct? Okay. Because on ISP, I'm saying 99.2 remote AS will be 100. So we need to go on ISP and then just to convert into the 200, correct? But if I want to change from 100 to 200, then we need to do this configuration on R1 and on ISP. And I don't have any access to, I don't have any access to do a change on ISP routers. So this is the problem actually, right? So how to resolve this problem? How to resolve this problem using the AS migration? Using the AS migration, we can resolve this problem. If I'm using here AS migration concept, then what happened? We need to do the change only on R1 router. No need to do any change on ISP. No need to touch this ISP routers. No. Getting a point?
Okay.
Okay. So it means in normal case, if I want to change the AS, so we need to do a configuration on ISP router as well as on R1 router. But when I'm using this AS migration command, or we can say AS migration concept, then what happened? No need to go on ISP router. Okay. Because I have only R1 router control. So I can do the change on R1 router and yes, it works. How? Now I can explain you. Okay, I hope the concept is clear, like why we are using this AS migration, right? And what is the profit of this AS migration? This is clear?
Kind of.
Okay. Now, let's start the practical.
Let's see the practical.
Yes. Let's take an example. This is the ISP one, and I'm changing the symbol here. Yeah. So this is what ISP router. And this is my company router, R1. Okay. Perfect. Now let's connect R1 with this ISP. Now let us start the device. And here I'm using what IP address? Let's say 99.1. And here I'm using what? 99.2. Okay. And this ISP router uses what AS number? 1000. And this router, R1 router, will use AS number what? Tell me. 100. Okay. Perfect. So let's do the configuration first. On ISP router, first of all, we need to configure the IP 192.168.99.1, 255, 255, 2500. Okay. And now let's go on R1 router. And on R1, we need to say what? Interface F0/0 IP address 192.168.99.2, and then say 255.255.250, and then say no what? No shut. Okay. Perfect. Now IP address is configured on both the sides, right? Now let's enable the BGP. Let's go on ISP1 and then say what? Okay, so on ISP1, what AS I'm using? Tell me.
You're in ISP1. Running BGP 1000.
100? Sorry, 1000.
Yeah, neighbor.
99.2.
92.
Remote AS will be what?
Remote AS is 100.
Perfect. It's 100. Super. Now let's go on R1 router again and then say what? Router.
Should be the other way around.
Router BGP and then say what? 100. And then say the neighbor. Who is the neighbor? 192.168.99.1. 1. And then say the remote AS will be what?
No, sorry. Wait, you're no. Yeah, you're right. Remote AS 1000.
1000. Correct. That's it. So wait for a second. The neighborship will be up. Everything is good then. Yes, the neighborship is up, right? Superb. Now if I'll show you, do show IP interface brief. Sorry. Do show IP BGP summary. The neighborship is up or not? So yes, the state will be blank. It means the neighborship is up, right? Superb. Now how to migrate the AS? Now I want to change this AS 100 to which? 200. Let's say I want to change this 100 AS into the AS 200, correct? Now, what I can do? First of all, what we need to do? We need to remove this AS here, correct? What we need to do? We need to remove this AS. So just to say router, no router BGP, and then say what? 100. It means first of all, we need to remove the older AS number, correct? The older AS number is what? That is 100. Now I remove this older AS and then say what? Router BGP, the new one, that is 200, right? Okay. And then say what? Neighbor 192.168.99.1. And then say the remote AS is what? That is 1000. And one more command we are using. We are using one more command, that is local AS. I'm using one more command, that is what? Local AS. And the local AS will be what?
100? I know 200. Oh, the local. Okay.
100. Now again the neighborship will be up. See? So what command I'm using here? Very simple. I can explain you again the command. Router BGP. Okay, the command is what? Router BGP 200, right? And then say what? Neighbor 192.168.99.1. Okay, I'm saying my neighbor is what? 99.1. And then say what? Remote AS will be what? 1000, right? It means I'm telling what I'm telling to my neighbor. What I'm telling to my neighbor, my local AS is what? 100. Okay, I'm telling right now my AS is what? 100.
Yeah.
But for ISP router, my local AS is what? 100. Getting a point?
Okay, so in this case, the ISP, which one is it going to receive? The BGP 200 or 100? Which one?
Wait. I can explain you. Okay. Actually, right now this ISP one will receive C. Do show IP.
Okay.
Oh, we need to do one thing. We need to advertise the route here first in BGP using the network command. First of all, we need to make a loopback. So let's say the loopback. I'll create a loopback 1. If I'll show the ISP one, so it will be show me what? Both A's. Getting a point? It will be receiving what? Both A's. So right now, what I can explain you on R1 router, are you understand how these commands are working and what is the meaning of those commands? Here I'm saying my neighbor is what? 1000, and but my local AS is what? 100. For which AS? For AS 1000, the local AS will be what? That is 100, right? But normally I'm using here the AS will be what? 200, correct? And see, I'll show you the neighborship. Neighborship is also up now. Done? Okay, so this is called what? This is called what? AS migration. This thing is clear or not? Yes, guys, please tell me.
Yeah, clear.
Okay. Or one more thing. Let's take an example. I'll stop. First of all, what I can do on ISP, say do WR. On R1 router, say do WR. Now what I can do, I can stop this topology. And let's say I'm having 3 ISPs. I'll take ISP connections from 3 different ISPs. Or let's say 2 different ISPs. This is what ISP2. And here I'm using what? 88.1. And here I'm using what? 88.2. Correct? Okay, so let's start the devices and configuration. Let's start the configuration. Let's go on ISP1 first of all. Check the IP address. IP address is done. And do show IP BGP summary. So BGP, okay, neighborship is also up. Great. So now what happened? What happening now? This AS also uses what? 1000. And this AS is also using 1000. So let's go on ISP2. Now here we need to say what? Interface F0 by 0, and I'll configure 192.168.88.1, 255.255.255.0, and then say what? No shut. Perfect. Now let's configure here what? Router BGP. Say 1000, and then say neighbor 88.2. Remote AS will be what? 100. Then say exit. Say do WR. Let's go on R1. And then say what? Do show run pipe section router BGP. First of all, I'm removing all the BGP on R1. I'll say no this BGP. And now I'm configuring what? Router. Because on R1 I'm using what? Okay, first of all, we need to configure the IP interface F1 by 0. Interface F1 by 0. IP address is what? 192.168.88.2.255.255.255.0, and then say no shut. Now just router BGP, and then on R1 I'm using what? AS. On R1 I'm using AS what? On R1 I'm using what? AS 100. Just to say here what? Router BGP, and then say what? 100, and then say neighbor 99.1, and then say remote AS will be what? That is 1000, and again we need to say the neighbor, that is 88.1, and then say remote AS will be what? That is 1000. Again the neighborship will be up. Perfect. So right now what happened? Let's say again in this company I want to change what I want to change the AS number, and right now the AS number is what? 100, and I want to change this AS number into the 200. So what we need to do? We need to
advertise,
disturb both the ISPs, right? So the best option is what? That is AS migration. Okay, and when you are doing any change in the AS, so your ISP router don't know actually. Okay, without disturbing to the ISP and without knowing to the ISP, you can change the AS number using the AS migration concept. So let's go on R1. How to configure the AS migration? First of all, do one thing. Remove the older BGP AS. No router BGP 100. Okay. Okay. After that, what we need to say? Just to say router BGP, and you want to change from 100 to 200. So just to say 200, and then say neighbor 190 to 168. 99.1. Remote AS will be what? 1000. And again, exactly same 88.1, and then say remote AS will be what? 1000, right? So once you configure this command, immediately it will be show you error, right? Immediately it will be show you error. Now just to use one more command what? Remote AS 88.1, just to say local AS will be what? That is 100. Now one neighborship will be up, and for another neighbor, that is 99.2, say the local AS is what? That is 100. See, this neighborship is up, 88.1 neighborship is up. Wait for a 99.1. 99.1 is not up. Why? Why 99 dot is not up? Give me a second. You need to check the command. Do show run pipe section router BGP. I'm also saying for this neighbor, which command? Local is 100 command. Now do show run pipe section router BGP. Okay. Now for this neighbor is also local AS, and this neighbor is also local AS, right? Now just to up this interface. Wait for a second. Now if I'll show you do show IP, still it will be showing me the errors. Show IP BGP summary. One is up, one is closing and idle, closing and idle. Wait again, just to say shut down this port. Need to check the command do show run pipe section router BGP. Everything is good. Oh, I'm sorry. Can you see here? I'm saying here neighbor remote AS is what 1000, and here I'm saying remote AS will be 100. So that is the
maybe 1000. That's wrong.
Yes, you need to change it in the 1000. And now do one thing. Now just to up this interface. So yes, the neighborship is up. Now if I'll show you what do show IP BGP summary. Wait for a second. Yes, now it is active, idle. Wait. Show me the idle. Yes. No. Still it will be show me the errors. Do show IP BGP summary. Again, we need to check what are the problem. Do show run pipe section router BGP. We need to check the command. Oh, one command is missed here. Local AS is what? 100. Now just to up this interface. Yes, now the neighborship will be up. See? BGP summary. Now both the neighborship will be up. And can you see here on R1 do show IP protocol, what AS I'm using? 200, right? But according to ISP1 and ISP2, this client will use AS what? 100, right? Clear now? Any doubt here?
Okay. Okay. So can you show me the commands again so I can write it down?
Yeah, sure. Do show. First of all, what do you need to do? You need to use this command. No router BGP 100. It means first of all we need to remove here this AS and then say do show run pipe section router BGP. Okay, first of all you need to use this command no router BGP 100, right? And using these commands. That's it.
Okay. Don't you mean no router BGP? Why 100 again? Because I see now it's 200.
No. Actually, previously at the first time we are running 100 AS, right? We are running
No,
100. So what
to
we need to
1,000.
do? We need to remove this 100 AS.
Okay.
And then again use the AS 200. Okay.
Okay.
Yeah.
Mm.
Hector, this is clear for you?
Yes. Okay, let me just copy again. 1 second. 1 second. Okay.
Okay. But the problem is what? Here we have a problem. What? Okay. Do one thing first of all. Let's go on every router and first of all we need to make one loopback. Do show IP interface brief. So here we have a loopback. So what I can do? Router BGP say 200 and then say network 1.1.1.1 and the mask will be what? 255.255.255.0. Sorry,
Okay.
it's 255. Perfect. Now if I'll show you do show IP BGP, so yes, it will be show me this route in the BGP table. Yes or no? Okay, that is fine. But the problem is what? You know, but ISP will check our routing table. Once this ISP will check our routing table, right? So do show IP BGP summary. Sorry, do show IP BGP enter. So can you see here?
It shows that
It
200.
will be show me now ISP one will check the client is having 100, but why it will be show me the 200?
Mm-hmm.
Right or wrong? Now ISP will know customer uses 200 as well. Let's say this customer don't want to tell the ISPs. This customer don't want to tell to the ISP that I'm using a 200 AS. Then we have one more command. The command is what? Router BGP. Say 200. Sorry. Say 1000. And then say what? Okay. First I'll say do show run pipe section router BGP. Okay. So not on ISP, I'm sorry, on R1. We need to say what? Do show run router BGP. Now I'm using what? Router BGP 200 and then say what? Neighbor remote 88.1 and then say 1000. Say enter. Say here what? Local AS. Local AS will be what? 100. And then say what? No prepend. It means using this command what happened? This 100 AS not prepending on the ISP router. Getting a point?
Okay.
Okay. Just to say what? Enter. Wait, the neighborship is down and up again. Now if I'll show you, show you on ISP 1. So do show IP BGP. See? Still it will be show me. Why? Because I'm using this no prepending for which neighbor? For which neighbor?
Oh,
88.1. And where is 88.1? That is ISP2. If I'll show you on ISP2. So they don't show me now 200 AS. See? Still it will be show me. Why? Give me a second. Do clear IP BGP start soft. R1 as well. Do clear IP BGP start soft. Let's go on ISP2 now. Now if I'm checking do show IP BGP, show me. They don't show me any effect. Why? Here also it will be showing me 100 and 200. Here also it will be showing me 100 and 200 BGP. Wait, give me a second. Let's go on R1. Router BGP say 100. Sorry, 200. And what is the command? This is the command. Just to say know this command. Then do clear IP BGP start soft. Show do show IP BGP. Router BGP. What is the problem? The problem for neighbor 88.1, that command is removed. For neighbor 88.1, router BGP say 200, neighbor 192.168.88.1, that local AS command is removed actually. That's why it will show me these errors. Now automatically the neighborship is up. See, the neighborship is up, but that command is not working. Do show run pipe section router BGP. The command is what? Neighbor 192.168.88.1 remote, sorry, local AS 100, and then say what? No prepend. Okay. This is not a full command. Like no prepend replace AS. The command is what? Replace. Sorry, no, I think the command is no prepend. Wait. Do show run pipe section router BGP. I'm using no prepend. Do clear IP BGP start soft. Show IP BGP. Do show IP BGP. Okay, let's go again on R1 and use the same command with replace AS. IP BGP start. Now on ISP, do show IP BGP. Yeah, now it is removed. So the full command is not only this command. The command is what? No prepend replace AS.
Okay, let me see.
Okay, so now ISP router not see any 200 AS. It means now ISP router don't know customer is using AS 200. Correct. Now if I'll show you on ISP 1, so right now ISP 1 will receive both, because for ISP 1 I'm not using that command. So let's go on R1 and then say what? The same command we need to use for which neighbor? 99.1 as well. Now the neighborship is down and then up. Just to use do clear IP BGP starts off, and then let's go on ISP 1 and then check do show IP BGP. So yes, now it will be showing me only 100, and ISP 2 is also showing me do show IP BGP 100 AS. Correct?
Okay.
Any doubt?
Can I see the command again, just to write it down real quick?
Yeah, sure. This is the command.
Okay.
Done? That's it. So this is called what? AS migration. Now let's discuss what? BGP default route. Okay. Now I'll open a topology for you. Okay. So this is the network, right? This is the company like network.com. Okay. And here we have, these are the two companies. This is the Palo Alto Networks and this is the Juniper Networks, right? And this is the customer edge. This is the ISP. These are the IP address here that I configured. And these are the loopbacks. This Palo Alto Networks having 200, 200, 200. This Juniper Networks having 100, 100, 100, right? And it uses AS200, it uses AS100, right?
Okay.
So let us start this configuration. Let's start these all the devices first of all. So first of all, let's go on R1 router, right? This is the R1 router. Okay. On R1, we need to check first of all, do show IP BGP summary. Okay. So right now R1 router will show me I have a one BGP neighbor with which with 55.55.55. I think this 55.55.55 is having customer edge router. Okay. This router having 55.55.55.55 loopback. So right now R1 neighborship with this router, correct?
Yep.
Okay.
Yes. Now let's check the customer router as well. Now, to show IP BGP neighbor, sorry. We need to say here do show IP BGP summary. So it will be show me I have two neighbors. The first is what 1.1.1.1. It means this customer router is also having a neighborship with R1 and with 99.99.99.2. It means with ISP router. Correct? Right or wrong?
Okay.
Okay. Now let's check this ISP as well. First of all, I can explain you the topology, like how this topology is configured and how this topology is working actually. Okay. Now, do show IP BGP summary. Here also it will be show me what 99.1 is my neighbor and 166 and 177 is my neighbor. It means 99.1 is what, that is customer edge router, and 77 is what, Juniper networks, and 66 is what, Palo Alto networks, right?
Okay.
Okay. Now, perfect. So this is our network. Now, if I'll show you the R1 router first of all. Do show IP BGP. So on R1, if I'll show you do show IP route. So sorry. do show IP BGP. So, okay, R1 router will receive 10.0 network. Okay, it means on R1 I'm using a network command with 10.0. And I can also see I can receive 100, 100, 100, and I can receive what? 200, 200, 200. It means this is what? What is this 100, 100, 100 and 200, 200? So it means right now R1 router will receive this prefix and R1 router is receiving this prefix as well, correct? Right?
Okay.
Okay, perfect. Now what happening? Right now R1 router, do one thing. Let's go on the customer edge router first. Router BGP 4000. And then say what? Now, yes, I can remove this route from here. Do clear IPBGP start soft. Okay, now what happening right now? What is the problem? The problem is what? If I'll show you the R1 router, do show IPBGP. So what happened? Do show IPBGP. R1 router is able to communicate to which one? 100.100.100.100. No. Okay, one more thing. One more thing, we need to go on the ISP router. On ISP, do show IP interface brief. Yes. So this ISP router is also having 8.8.8.8 IP address. And this is what, let's say this is google.com. Okay. So let's go on the PC one. Let's do this. Let's do the communication. Hundred dot hundred dot hundred dot hundred. And then say enter. So yes, this PC is able to communicate. Yes or no? This PC is able to communicate 100 and 100, and this PC is also able to communicate 200.200.200.
Yep.
So yes, this PC, both the PC is able to communicate to this. This let's say what happened. Let's say this is these are the company, okay, and this is the headquarter of the company, and this is the branch number 1 of the company, and this is the branch number 2. It means these all are the same company. Okay, these all are the same company, but are in the different location, right? Let's say this company having the location will be what? India. Okay, this company having the location will be what? Dubai, right? And this company is what? From US, right? So this is the same company, and these three companies, the company having 3 branches, and let's say this is the headquarter. Okay, so in this time what happening? obviously I want to communicate to my these employees wants to communicate where wants to communicate to the another branch. So yes, this right now this PC, this headquarter is able to communicate to another branch. Yes, I'm able to communicate. Okay, now 200.200.200.200. Yes, this headquarter is also able to communicate, right?
Okay.
Okay. Okay. Now but these employees not able to communicate with the google.com. See, okay. So the problem is what? Right now, these employees able to communicate to different branch, but these employees is not able to communicate to the google.com, right?
Okay.
So this is the problem. So how to resolve this problem? Let's go on the customer edge router. Do show IP route. So can you see here in the customer edge router, I'm configuring a default route towards the ISP, correct?
Okay.
Okay. On ISP, on customer edge router, right now, okay, if I'll show you ping 100.100.100.100. I want to communicate to this 8.8.8.8. So yes, I'm able to communicate. Right? Customer edge router is able to communicate to the ISP. Why? Because customer edge, inside the customer edge router routing table, we have a default route, because I'll configure the default route pointing towards the ISP. Clear?
Okay.
But the problem is what? My PC is not able to communicate to this 8.8.8.8. Why? Okay, I'm giving you a reason. Why? Actually, what happened? Once I'm communicating from this PC to 8.8.8.8, so the source IP will be 10.1, destination IP is what? Yes, 8.8.8.8. So this PC will forward this packet to the switch, which will forward this packet to the router, correct? Okay, switch will forward this packet to the router. Okay, now once this R1 router will receive the packet, with source IP 10.1, and the destination IP is what? Yes, the destination IP is what? That is 8.8.8.8. Now R1 router will check the routing table. Inside the routing table, we have any 8.8.8.8 route. Can you check it? No, we don't have. So how this router will forward the packet? That's why this router will R1 router will drop the packet on R1 router. Correct? So this is the problem. So but this customer router, if I talk about the customer edge router, so this customer edge router is able to communicate to this 8.8.8.8. So actually what happened, if I'll show the customer edge router routing table, do show IP route. So yes, here I'll configure what? Here I'll configure what default route pointing towards ISP. That's why this customer edge router is able to communicate. But what is the problem? Right now this customer edge router is not sharing this route to the R1 router. Once this R1 router is also receiving the default route, then yes, this R1 router is also able to communicate. But right now the problem is what? This R1 router is not able to receive this default route. So what we need to do? We need to go on the customer edge router and then say what? Router BGP, say what? What BGP is I'm using here?
BGP 4000?
I think yes. Yeah, it's 4000. So what we need to say? Router BGP 4000, and I'm using what? Default information originate. Say enter. So once I'm using this command, what happening? Immediately this router will check the routing table. In the routing table, we have any default route? Yes, we have. So what this router will do, this customer edge router will propagate this default route in the BGP domain. Now if I'll show you on R1 router. So see, previously they don't show me any default route in the routing table. Now if I'll show you, so yes, it will be show me default route in the routing table, correct?
Okay.
Now if I'm going to this PC1 and wants to communicate 888, so yes, now I'm able to communicate. So it means what this command will do actually, what this command will do, default route or originate command. Using this command, we can propagate a default route in our BGP domain, right? We can propagate a default route in our BGP domain, right? But the concern is what right now, what happening? I also configure the BGP in between customer edge and ISP, and I also configure the BGP on customer edge and in between R1, right? So what this customer edge router will do right now, this customer edge router will forward this default route to ISP as well as this R1 router. And I don't want to share this default route to this ISP actually. I want to share this default route in my internal domain, not to the ISP, right? So this is the problem. Now how to resolve this problem? Just to do one thing, just to know this command, okay? Yeah, just to know this command and use the different command. That command is what? I want to share this default route to my neighbor 20.1. So just to say default originate and then say enter.
Or remove us.
Specify. Okay. R1 is my neighbor. I think R1 in between customer 1 and R1. I'm creating a neighborship using the loopback. I think we need to check it. BGP summary. Yes, my neighbor is what 11111. So we need to say what neighbor. Sorry, router BGP. Say 4000. And neighbor we need to say 1.1.1.1 and just say what default originate and then say enter. Do clear IP BGP start soft. Just to say exit. And let's go on R1 router now again. So yes, now it will be show me do show IP route. So it will be show me the default route here, right? But now if I'll show the ISP router, so they don't show me here the default route. Here I'm not receiving any default route from the customer. Done.
Okay.
So this is the default route command. We are having two commands here. Okay. Yes. And one more thing. Okay, one more thing. I can try one more thing here. On the customer edge device. On pipe section router. BGP. And then say what? Just to remove this command first. I'm trying one more command actually here. So let's go on the customer edge router and then say router BGP. Say 4000. Okay. 0. Yes, perfect. What happened? I'll say no this command. You know, guys, I told you what is the work of the network command. Can you explain me what is the work of the network command? You know, I told you whenever if I'm entering a network command, so what that command will do, that command will check the routing table. That route is available in the routing table or not, right? So I'll say here what 0.0.0.0 and then say what mask 0.0.0.0. So this is the default route, right? Now this router will check in the routing table We have any default route? Yes, we have. So I think it will be share the route to the R1 router. Wait. Show IP BGP. Yes. Perfect. Show IP route. So you can also propagate a default route using the network command as well. Still, this customer, this employee is able to communicate to this 8.8.8.8. Done. It means using the network command as well, you can propagate the default route. Clear?
Okay.
We have 3 commands to propagate the default route in the BGP. The first command is what? That is router BGP, say 4000, and then say what default route. Default information originate. This is the command. So this is the first command. After that, second command is what? Neighbor command. Let's say I want to share this default route to my particular neighbor. There is 20.2 and then say default originate. So this is one more command. Oh, I'm sorry. Just to say here, neighbor 1.1.1.1. Then say default originate. This is the command, and the second command using this command, using the network command as well. We can propagate the default route. Correct. So we have 3 commands. Clear? Any doubt?
Can I see them by order? Because I mean, problem is like they're pretty far apart.
What can you repeat again?
The commands. Can I see like what steps you need to make to create them again?
Yeah, sure. Wait. First of all, it is network command. I'll say no this command. Default route command. I'll say no this command. And then say BGP law neighbor network. Now if I show you on R1, so do show IP route. So they don't show me any default route. Yes, it will be show me still. Do clear IP BGP start soft. It will be showing me the default route. Why? Let's go on the customer device. I'm not doing anything else here. Wait. We need to check do clear IP BGP star. I'll show you an R1, so they don't show me any default route here, right? Okay, now the first command is what? Router BGP, say 4000, say enter, and then say what default route, default information originate, say enter. Just to say do clear IP BGP star and then say soft. Now if I'll show you on R1, do show IP BGP. So yes, on R1 it will be show me the default route, and the routing table as well. It will be show me the default route, correct? So this is the first command.
Okay.
Okay. You write this command.
1 second.
Okay. Now I'll remove this command and then again say do clear IP BGP start soft, because BGP will say whenever if you are removing and adding anything else, so just to use this command. Okay. Now again, if I'll show you, I'm remove this command default route. So now if I'll show you again the routing table of R1, so they don't show me the default route in the routing table, right?
Okay.
Now again, I'm using a second command, that is what? That is neighbor 1.1.1.1, and then say what default originate, say enter, and just to use do clear IP BGP start soft. Okay. the R1 router, again we need to check the routing table. So again it will be show me the default route in the routing table. Correct?
Okay.
So this is the second command. You write this command, write this command.
Okay. Got it. Okay, got it.
Perfect. Now let's remove this command as well. I'll say no this command and then say do clear IP BGP start soft. Okay, again we need to check on R1. Now again they don't show me the default route in the routing table. They don't show me the default route in the routing table, right? Now the last option will be what? Using the network command. Because first of all I'll show the routing table. Sorry, first of all I'll show the default route in the customer edge router. So yes, this default route it will be shown in the routing table. So when I'm using the same command network mask 0000, then automatically after entering this command, first of all this router will check inside the routing table. We have this default route. Yes, we have. Now immediately they will share to the R1 router. See, using this command as well, it will be propagate the default route in the BGP domain. Clear? Any doubt?
Okay.
So these are the three commands. Okay. But if I ask a question like what are the difference in these three commands? Okay. Again, I can explain you. I'll say no this command and then say do clear IP BGP star soft. Okay. Now again I'll show you on R1. So they don't show me the default route. Do show IP route. See, they don't show me the default route here. Correct? Right or wrong?
Correct.
Now, okay. Do one thing. Okay, first of all, can you tell me in the routing table we have a default route or not on edge router? Yes, we have a default route. So first of all, what I can do, I'm removing this default route in our routing table. Because statically I'm configuring the default route pointing towards ISP, so I can remove this. Okay, I'll say no. Now again, if I'll show the routing table, do show IP route. So can you see here the default route is available or not? No. Right. So okay, this thing is clear to you. Any doubt?
Okay.
Okay. Now again, I'm saying what right now on customer edge router we don't have any default route. Now I'm saying what router BGP and then say what 4000 and I'm using what default information originate command. Say enter. Say do clear IP BGP start soft. And let's go on R1 and check the routing table. Do show IP route. Can you see here? It will be showing any default route here. It will be showing any default route? No. Why? Because when you are configured this command default route originate in any router. So it must be the default route is available must be in the routing table. If that default route is not available in the routing table, then this command is not working. They don't propagate the default route to the another router. Clear?
Okay.
Okay. It means when you use this command default information originate, so it must be default route is available in your routing table. Clear? Now I'll say no this command and then say do clear.
So if we
Do
want to
clear
use
IP.
this, one question, if you want to use this command, how do we do it? Do we have to also configure the default information originate on the R1?
No. What we need to do, we need to go on customer edge router in the same router. Okay, in the same router, we need to configure this default route. This one, this default route.
Okay.
Manually. Okay. Now I'll say do clear IP BGP start soft. Let's go on R1. Okay, now I'm using one more command, that is neighbor command. Still, if I'll show you do show IP route. So inside the routing table, we don't have any default route in the routing table, right? And now I'm using the second command, that is neighbor 1.1.1.1 and the default originate. Say enter. Do clear IP BGP start soft. Say enter. And let's go on R1 and then say what do show IP BGP. IP route. Can you see here? The default route, it will show me yes. So it means here the default route is not available, but still using this command, which one? This command, that router will propagate the default route in our BGP domain. Okay. It means using that command, the first command, that default route should available in the routing table, but using this command, if the default route is available or not, still they will be propagate a default route in our BGP domain. Clear?
Okay.
Okay.
Okay, perfect. Now again, just to remove this command, here IP BGP star soft, and again let's go on R1 router and let's check again the routing table do show IP route. Now they don't show me the default route. See, they don't show me the default route. Now let's use the last command, that is network command 000 mask 000 enter. Do clear IP BGP star soft. Now if I'll show you on R1 router, so they don't show me the default route. See, they don't show me the default route. So it means using this command as well, the net inside the routing table, the default route should available in the routing table, then only this command will work. Clear?
Okay.
Okay. So we have 3 commands. Here, default route, okay, BGP default route, we have 3 commands. First, second, and then what, third? Okay. What happened in case of first command? The first command is what? Route
Originate.
originate. In this command, what happening? Okay, in routing table, and after that we have one more command, neighbor command. Neighbor 1.1.1.1. Default originate. Using this command, what happening? Default route is available or not. This command, till this command will propagate the default route to our BGP domain. Clear? After
Okay.
that, we have one more command, that is network command. Using this network command, in this time, what happened again? Default route should be available in routing table. Then only it will get the default route in our BGP domain. Clear?
Okay.
Any doubt? I hope this is clear to you, correct?
1 second, let me just write it down.
Yeah.
Yeah,
True.
you can read it. And I can also copy paste this on your chat.
Like that because my chat doesn't work.
Yeah, no problem. You can write that. You can write it. No problem.
What? Can't see right now.
Yeah, give me a second.
Mm-hmm.
Yeah, now you can write it.
Okay, thanks. Okay. Okay, I'm done writing, huh? Just in case.
Yeah, me too.
Let's say this is the topology, right? Okay. Okay. So what is ORF actually here? Right now, what happening? This Juniper networks will forward our 100.100.100.100 route to customer edge router, and this FortiGate networks is also Palo Alto networks is also share 200.200.200.200 route to customer edge router. Right or wrong?
Yep.
Right.
Mm-hmm.
Okay. Okay. So right now what happening? This ISP will forward 100 dot 100 dot 100 dot 100 route, and this ISP will forward 200 dot 200 dot 200 dot 200. Correct?
Yep.
Right or wrong? Okay. Super. So this ISP router will forward 100 dot 100 dot 100 and then 200 or 200 or 200. Let's say what I want. This customer don't want to receive this 100 or 100 and 200 or 200. So what is the option? Tell me. What we need to do? Let's say this customer edge router, this company don't want to receive 100 or 100 and 200 or 200. Then what we need to do? Tell me.
Filter those prefixes.
Perfect. We need to use what?
Filtering.
Filtering. Superb. So if I'm using a filtering, so what happening? Like ISP router will forward this route to the customer edge, and customer edge router is not able to send this packet and send these routes to internal route, right? Or we can say customer edge router is not receiving those routes 100 or 100 and then 200 or 200. Correct? Okay.
Exactly.
But here we have an option, that is what ORF. ORF stands for outbound route filtering. What we call?
Outgoing.
No, outbound.
Outbound.
Route filtering. This is what ORF. Okay. So what happened? Actually, once we configure ORF on customer edge router, it means when we run the command on customer edge router, so this ORF will affect not on customer edge router. No. Once, what I can explain you again, I can repeat this point. Once we configure ORF on the customer edge router, then what happened? This command will affect on ISP side.
Really?
It means once we configure ORF on customer router, so this command will affect on ISP router. It means once I configure ORF on customer edge router, so what happened? This ISP is not able to share this route from our side.
Okay.
It means this ISP is not able to send out this route to the customer, towards the customer. Correct?
Okay.
It means this is what once we are using the command on customer device, but this command will affect on the ISP side because we don't have power to change the ISP, right? Because we don't have any control to the ISP. We have control to the customer edge router, right or wrong?
Exactly.
So it means using the ORF, what we can do, we can run the command on this device, but that command will affect on the neighbor device. So this is actually, this is also type of filtering, but normally what happens? If you are deny this route on ISP, then ISP is not able to forward the route towards customer edge router. But right now, I'm not doing any configuration on ISP. I can do the configuration on the customer edge router, and this configuration will affect to the customer router. It means customer router is not able to exit the packet from here. Okay? These two routes. That's why we are using this ORF. So let's do the configuration. First of all, let's go on the customer edge device. First of all, I'll show you like I'm receiving or not.
Okay.
Those routes.
It is there, right? Yeah.
Do show IP BGP. So yes, I can receive, right? I can receive 100 or 100 or 100, right? As well as I can receive what 200 or 200 or 200. Okay, do one more thing. You know, in the default route, I can remove the default route. So again, I'm configuring a default route. Once I teach you default route propagation command, then automatically I can remove that So now I can configure it. It will be shown in the default route, and I can propagate this default route using the network command. Okay. So now what is the concern? If I'll show the customer is routed do show IP BGP. So yes, it will be show me I can receive 100.100.100 and I can also receive 200.200.200. And I don't want to receive those routes, but I enter the command on the customer edge device and that command will affect on the ISP routers. Okay. So let's go on the customer edge device. Okay. First of all, here we have a command. The command is what? Router BGP. And then say 4000. And then say what? Neighbor 99.99.99.2. And here we have a command capability ORF prefix.
Oh, look.
Send.
Wow. Okay.
Say enter. Okay. So here we have actually two commands. The command is what? Here it will be show you two things. Receive and send. Okay. Receive and then what? Send. So on customer side, always we need to say what?
Receive,
send,
right?
because this is the customer device, right? Okay, now let's go on the ISP router. And I'm using the same command on ISP router as well. Router BGP say 66666 and then say what? Neighbor 99.99.99.1 and then say what? Capability ORF prefix list. Here we need to say what? Receive.
But in
Okay.
this
So
case,
receive command always.
But in this case, if you are, for example, the customer edge router, which is our case, in this case, if we want to use this command, we will have to contact the ISP. So they also configure from their side.
No. Actually, what happens? See, actually, what happened? Once you take any ISP connection from the ISP, so by default, this command is entered from the ISP side by default. So no need to say to ISP to enter this command. Only we need to enter this command on the customer's device. By default, this command is enable on the ISP end actually.
Okay.
Okay. Yeah. Now, so first of all, on customer side, I'm using a send command. On ISP side, I'm using what? Receive command. All right. Capability ORF prefix list receive. And on the customer side, I'm using capability ORF prefix list send command. Perfect. Wait. Yes, done. Okay. Now what we need to do? Now let's go on customer edge router again. Okay. And in this customer edge router, just to make ACL access list. No, here we don't have power to add the ACL. We need to use prefix list. So just to say IP prefix list and then say deny. Or I think you need to specify the name. Yeah, its name is CCIE. Deny. And I'll say what? I'll say deny. I don't want to receive which one?
Okay.
100.100.100.100. And then say the slash value will be what? 32, right? Exactly same. I don't want to receive. 200.200.200.200/32. Clear? Now if I'll show you the prefix list, do show IP prefix list, say enter. So yes, it will be show me two prefixes lists. Okay.
Okay.
Wait. Here two prefix list is like the different previous, the older prefix list is also there, so I can remove it. Now I'll make only these two prefix list. Which one? These two. Clear? Okay. Done. And you know, these are the deny statements. So after deny statement, one permit statement is mandatory, right? So just to say IP prefix list CCIE, and then say what permit 0.0.0.0 /0 less than 30. Say enter. This thing is clear to you? Any doubt here? So I'll create here three access list. I'll say deny 100, 100, 100 because I don't want to receive this 100, 100, 100. And I'll say deny, I don't want to receive 200 or 200 or 200, right? And why I'm using this command to permit remaining traffic, right? Okay.
The remaining
Clear?
traffic.
Clear? Yes. Super. Now what we need to do, just to use a command, router BGP, say 100, not say 100, it's 4000. And then say what neighbor, who is the neighbor? Right now the neighbor is what 99.99.99.2. And then say what? Okay. Here I want to add the prefix list. Okay. So your prefix list name is what? CCI. So just to say here what? CCI. And then say we need to say in or out. So just to say in. Because what happened on a customer edge device will receive the route. So when I'm saying the in here, so it means on ISP side, it will be effect to the all outside. If I'm saying here in, then it will be effect on ISP side out. If I'm saying here out, then on ISP side, it will be effect on the inside. Okay. Clear?
Clear.
Perfect. Now, just to say in, and then say enter. Do clear. IPBGP, start soft. Right. Now if I'll show you, do show IPBGP. So can you see here? I'm not able to receive those routes.
Okay, where did you apply this filter?
What?
Where did you apply this filter? On the interface or where?
No, inside the BGP.
Inside the BGP. Okay.
Yes. What are the commands? Again, I'll show you. Do show run. Pipe section, IP, prefix list. So these are the prefix lists that I'll make here to these permit like deny statements, and this is the permit statement, right? After that, I'll make here what? Just to add this, do show run pipe section, router BGP, and I'll add this prefix list inside the BGP directly.
Okay.
Using this command.
Okay.
And you know, I also use the capability command. So this capability command is mandatory on customer side. We are using send capability. On provider side, I'm using receive capability command, right? That's it.
So you have
now,
to put, you have to put this command all the time, right? Always.
Yes. Yes.
Okay.
It means customer side. I'll show you the ISP router. So yeah, this is the command. Okay. Neighbor, this is the capability command, receive command, and on customer side, side, always we need to use send command. Okay, on ISP side, always ISP uses what? Receive this command. Okay, this command is by default enabled on ISP side. So that's it. This is the configuration, and this is called what? ORF. Why we are using ORF? Because we don't have any access to do anything on ISP, right? So when we do anything else on the customer's device, so that is effect on the ISP side actually. Okay. Now ISP router is not able. Okay. This ISP router not able to out any prefix from here to this customer. Okay. This ISP router is not able to share to this customer 100, 100, 100, and then 200 or 200 or 200, right? Okay, let's say I want to share, 100 or 100 or 100, right? So let's go on the customer. You know, you remember, like I'm creating a prefix list here.
Yeah.
And let's say I don't, I want to receive this 100, 100, 100. So just to remove this 100. Just to remove this 100, 100, 100. Okay. Now if I'll show you, okay, do one thing. Just use what? Do clear IP, BGP start soft. Okay. Now if I'll show you on the customer device, do show IP BGP. So see, no, wait. Do clear IP BGP start soft. Now I need to check do show IP BGP. So yes, I can receive this 100, 100, 100, right? Now it will be deny what? It will be denying 200 or 200 or 200. Clear?
Clear.
So this is called what? ORF in the BGP. Clear? It means ORF is look like a filtering, but in case of filtering, what happen? They will affect on that device, like on the same device, but this ORF will affect on the neighbor device. Clear? Yes. So now, perfect. That's it. Now let's remove it from here. Done. Now if I'll show you the customer device, do clear IP BGP start soft. So yes, now I can receive both the route in the routing table, the BGP table as well. See, now I can receive 100 and 100, and then what I can receive 200 or 200 or 200. Clear?
Clear.
Any doubt?
No.
Super. Okay. Now that is fine. Super. Now the next topic is what?
Conditional route advertisement.
Conditional route advertisement. It means here we are making a condition. How? Okay. Right now what happening? Okay. Let's go. Okay. Can you see here, guys? Here we have a two branches, Juniper and Palo Alto networks, right? This is the Juniper network and this is the Palo Alto network, correct? So let's go on the Juniper router. Let's go on the Juniper networks. And I'll show you the routing table of Juniper networks first. Do show IP BGP. So, can you see here? It will be receiving this 10.0 network, correct?
Yeah.
And where is 10.0 network in this topology? Tell me.
Which one? Show me.
10.0 is here, right?
Mm-hmm.
It means this is the 10.0 network here, right? What happened actually? This R1 router will share this prefix, this 10.0 to the customer edge. Customer edge will share this to the ISP. ISP router will share to these two branches. Clear? So that's why this Juniper networks. That's why this Juniper networks will receive this 10.0 route. Correct?
Mm-hmm.
Exactly same thing on Palo Alto networks as well. If I'll show the Palo Alto networks. So give me a second. Do we show IP BGP? So yes, I can also receive this 10.10.10.10, correct?
Mm-hmm.
And this 10.10.10.10 is come from where? Come from this LAN, because this LAN is what? 10.0 network. It means R1 will share to customer edge will share to ISP, and ISP will share here. Okay. Now let's go on R1 router. And I'll show you one thing here. Guys, can you see here? On R1, what I'm saying here, do show run pipe section router BGP. Wait for a second. Here actually I'm using a network. What happening? I'm using a network command 10.0. I'm using this command here, network 192.168.10.0 mask 255. Sorry, 255.255.255.0. I'm using this command on R1. Now what this R1 router will do? This R1 router will share this 10.0 prefix to customer edge router. Customer edge will share this prefix to ISP. ISP will share to these routers. Yes or no? Clear?
Yeah.
Okay. Perfect. And now if I'll show you on R1 router routing table, it means, let's say what I can do. Let's say I'll say know this command. Do clear IP BGP starts off. Let's say I'll know this command. Now what happened? Now if I'll show you on Juniper networks. So can you see here previously it will be show me a 10.0 route. Now again if I'll show you do show IP BGP. Now they don't show me 10.0 route here, right or wrong? And if I'll show you on the Palo Alto network, so do show IP BGP. Now they don't show me the 10.0 network. Yes or no?
Mm-hmm.
Why it is not showing me? Because I'll say no this command, right? Then if I want to show, then what we need to do? We need to say yes this command. Clear? Do clear IP BGP star soft. Now if I'll show you on Juniper network again, if I'll show the BGP table, do show IP BGP. So yes, now it will be show me the 10.0 network, right? Okay. On Palo Alto network here also, do show IP BGP. Yes, it will be show me the 10.0 network, correct? Any
Okay.
doubt?
No.
Super. Exactly same happen. What? If I'll show you R1 router routing table, do show IP BGP. So right now R1 router will receive 100.100.100 and then what 200.200.200. Why? Because on the Juniper network, I'll show you do show run pipe section router BGP. Here I'm using network command 100.100.100.100. That's why what this router will do, this router will share this prefix. Now let's say I'll say no this command and then say do clear IP BGP star soft. Okay. Now if I'll show you on ISP, see previously ISP will receive this 100.100.100. Now again if I'll show you, so they don't show me 100.100.100 route, correct? Okay. Exactly same. Let's go on the Palo Alto network and then say what do show run pipe section router BGP, say enter. Sorry. Not BGP, is the BGP.
Geo.
Yeah. Now if I'll show you on Palo Alto network, like in this router, so here also I'm using a network command, right? Let's say what I can do. I'll say know this network command, right? And then say do clear IP BGP start soft. Now if I'll show you on this R1 router, so now they don't show me 200 route as well in the routing table, right? Or
Yeah.
It means when this R1 and customer edge router will receive 100 and 100 and 200 or 200 route, when let's go on here and then say network command on Juniper networks, and on Palo Alto networks as well, we need to say network command. Do clear IP BGP start soft. Here also we need to do the same command, do clear IP BGP start soft. Okay. Now if I'll show you on R1 router, see previously I'm not receiving 100 and 200 route. Now again if I'll show you do show IP BGP, so yes, it will be receiving 200 or 200 or 200 and then 100 or 100 or 100. Clear?
Yeah.
Okay. Now what I want, now I'm telling you what is conditional route advertisement. So
Which was,
actually here we are making a condition. What condition? Okay, this customer edge router, this router will make a condition. What if customer, okay, here I'll make a condition when this customer edge router will receive 100.100.100 and 200.200.200.200 inside the routing table, then only this customer edge router will share 10.0 route to here and here. You remember what happening here? R1 router will share 10.0 prefix here, right or wrong, towards ISP, and ISP will share 100.100.100.100 and then what? 200.200.200.200, right or wrong?
Yeah.
So in this condition, what happening? This route is going out from here and these two routes is come in from on customer edge router. So on customer edge router, I'll make a condition here. What? When these two routes is available in routing table, then only this R1 router is able to share this 10.0 route to the ISP. Yes or no?
Yeah.
Yeah. So using the conditional route advertisement, we have power to make a condition. Here I'll make a condition whenever I'm receiving these two routes, then only if it means if these two routes are exist in the routing table, if these two routes are available, or if these two routes are exist in the routing table, then only this customer edge router will advertise, or this customer edge router will share this route or share out this route to the ISP. Clear?
Yeah.
Okay. Okay. It means what happening? These two routes are what? These two routes are exist. When these two routes are exist, then this customer edge router will advertise 10.0 route to out. Correct? Okay. Perfect. Now how to configure? How to configure it? Okay. Okay now. So first of all, let's go on the customer edge router. Okay. So first of all, let's go on router. And then say what access list 10. Okay, I'll say what access is 10. And then say what permit. Okay, permit. And then say what? I don't want to receive 100 or 200, right?
Yeah.
And I want to say here what? When I receive this 100 and 100 and 200 to 200, then this customer edge router will share 10.0 prefix to ISP, right? So I'll say 100. Duplicate permit statement ignore. I think
you already have that. Seems like
access list is same access list is created here. Yes. So just to say no, and this is also just to say no. Now again, I'll create access list. I'll say access list 10 permit and then say host 100.100.100.100. Say enter, correct? And I don't want to add one more 200.200.200.200. Clear?
Yeah.
Okay, perfect. Now what I can say, I'll say what route map. And then say what the name is what exist. And then say permit. Why I'm saying the exist? Now inside the exist, I'm saying what match IP address 10. Are you getting the point? What I'm doing right now? I'll create a two ACL.
2 permits.
100 and then what 200. And the name is what 10. And I can add these both the ACL inside the route map. Here the route map name is what exist.
Okay.
It means what I'm saying, when these two routes are available or exist, 100 and 100, 200 or 200 or 200. When these exist.
The access list can have the same number in this case? Like the same,
yes.
Access list 10, access list 10.
Yes.
Okay.
Okay, because I'm saying here what? Whenever if these two prefix are received, then only just to out that route, okay?
Okay.
That 10.0 route. Now I'll say what exit. Okay, now again what I can do? Again, I'm making a ACL access list. Now the name is what 20. Okay. Again, I'm making, first of all, I'll make this one. Okay. Now again, I'm making a ACL access list 20 and then say permit. Host will be what? Or we can say 192.168.10.0, 0.0.0.255. Okay. So first of all, what I can do here, I'll make two ACL and these two ACL I can add here in which route map? The route map name is what exist. I can add these two ACL in exist route map, correct? And again here, what I can do, I'll create a ACL, right? Okay. I'll create a ACL. After that, what I'm saying, again, I'm creating a route map, and then say what? Advertisement. Permit. Okay. And then say what? Here his name is what exist, and here I'm saying what 10, right? And here I'm saying what match IP address, and I'm matching this ACL here 20. Done. What I can do? First of all, I'll make these two ACLs, right? And these two ACLs I'm adding in this route map. That route map name is what exists. Okay, these two route map I can add in this. These two ACL I can add in this inside this route map, right? Correct. Again, I'll create one ACL, and this ACL I can create one more route map. That name is what advertisement, and this ACL now we can call inside this route map, correct? It means what happening? Okay. Here I'm saying what? First of all, I'll create two ACLs, right? And then ACL name is what? That is 10. Okay. And I'll create a route map. That route map name is what? Exist. And inside the exist, I can add this ACL, right? Okay. Now again, what I can do? Again, I'll create this ACL. Here also, what I can do, I'll create one ACL, and this ACL I can add here in which route map? Route map advertisement. It means that route map name is what? Advertisement. Okay. So it means this 20 ACL I can add inside a route map advertisement, and this 10 ACL I can add inside the route map exist. Okay. Clear now?
Yeah.
Super. Now just to say exit. Now what I can do? Okay. I'll create a two route maps. Okay. I'll create two route map. One route map name is what? Exist.
Yes.
Second route map name is what? Advertisement. Right. And in this advertisement, we have 10.0 prefix. In this exist, we have 100.100.100 and then what? 200.200.200. Yes or no? Okay. Perfect. Now, very simple. Just to go on customize router and then say what? Router BGP. Say 4000 and then say what? Neighbor 99.99.99.2. Okay. And then say what? Advertised map. Okay. It means what it will be show you? It will be show you just to tell me what is your advertised map name. So my advertised map name is also advertisement. Advertisement. So I'm adding this advertisement here. And then again, it will be show me what? Just to tell me your exist map name. So I'll say my exist map name is also exist. And I'll say what? Enter. That's it. What is the command? Again, I can explain you these commands. Okay. So what I can explain you now. What I can explain you now. First of all, here what happening? You remember? I'll create a route map. That name is what? Exist. And in this exist, we have two ACL, right? 100.100.100 and then what? 200.200.200. In this advertisement route map, we have a one ACL that is 10.0. Correct? Right or wrong? This thing is clear? Hello?
Yeah.
Okay. Now what I can do here, I'll say what? Neighbor 99.99.99.2. I'll say what is the, tell me what is the route map of advertisement. So my advertisement route map name is what? That is also advertisement. Correct? So I'll say here what advertisement. And then I'll say, please tell me the exist map. Exist map, route map name is what? This is also exist. So I also say exist. It means whenever these routes are exist, which one? Whenever this route map are exist, this route map is what? Exist. Inside the exist route map, we have what? 100, 100, 100, and then what? 200, 200, 200. It means what I'm saying here, whenever in this routing table 100.100.100 and 200.200.200 are exist, then what we can do? Then just to advertise inside the advertisement, we are saying what? 10.0. Then advertise out 10.0 route from here. Correct? Okay.
Yeah.
Now I'll show you here. Now I'll show you here just to say exit. So right now what happened? Do show IP BGP. Okay. Right now I can receive this 100.100.100 and 200.200.200. That's why what happened? That's why what happened? This ISP router will receive that route. Which one? 100.100. Sorry, 10.0. See, ISP router will receive 10.0 route. Why? Because right now it means what happened? Once the customer edge router exists this 100.100 and 200.200.200, then only this customer edge router will out 10.0 network. Okay. This thing is clear?
Yeah.
Okay. Let's do one thing. Let's go on R1 and then say what? Router BGP. Say 4000. Okay. And then say what? Network. You know, here this command is running, right? What I can do? I say no this command. No. Let's say I'm not saying no this command. I'll say enter this command. Okay, right now the condition is what? When this customer edge router will receive 100.100.100 and 200.200.200, then only this customer edge router will send 10.0 route out towards ISP, right or wrong? Now I can do one thing. Let's go on edge routers. Sorry, let's go on the Palo Alto routers. And then say what? Router BGP. Say 2000. Network 200.200.200 say mask 255.255.255. I'll say no this command. Okay, and exactly same thing we need to do on Juniper networks as well. Router BGP say 1000. Network 100.100.100.100 mask 255.255.255.255. What I can do? I'll say no this command and then do clear IP BGP start soft, and on here as well do clear IP, do clear IP BGP start and then say soft. So once I know this command on here or here, then what happened? This customer router is not able to receive 100 or 200 route, right or wrong? And I told you, I make a condition here. When I'm not receiving 100 or 200, then this customer edge router is not sharing this 10.0 to the ISP, right or wrong?
Okay.
So now let's go on the ISP because on Juniper router and Palo Alto router, I'll say what? No this command, right? I'll say what? No that 100 or 200 prefix. Now if I'll show you on customer edge router, do show IP BGP. So I'm not receiving 100 or 200. See, I'm not receiving 100 or 200. If I'm not receiving 100 or 200, so this customer edge router don't share this 10.0 prefix to the ISP. I'll show you the ISP. See, previously ISP will receive this 10.0, but now if I'll show you, do show IP BGP So I'm not receiving 10.0 route here, right? Okay. Why? Because customer edge router is not receiving 100 and 200 route, right? Again, what I can do? Let's go on the Juniper router and then say what? Enter this command 100 and on Palo Alto as well. Enter this command and then say do clear IP BGP start soft. Here as well I'm using do clear IP. Do clear IP BGP start soft, say enter. So now if I'll show you, so yes, this customer edge router will receive 100 or 200 route.
200.
Till now I'm not receiving 200. Wait. Yes,
I
now
don't
I
know.
can receive 100 or 200. And if this router will receive 100 or 200, now this customer router will share 10.0 route towards the ISP. I'll show the ISP. See, previously I'm not receiving any 10.0 route here, right? Now if I'll show a do show IP BGP, so yes, I can receive, wait for a second. Just to use do clear IP BGP start soft. Now let's check on ISP. See, now I can receive 10.0 route here. Clear?
Clear.
Any doubt? So using the what is this? This is called what? Conditional route advertisement. It means here we are making a condition. Okay. I'll make a condition here. What? I'll make a condition here. What? When customer edge router will receive these two routes, then only this router will share this towards ISP, right? Okay. Any doubt here?
No.
That's great.
Okay, so sorry
Again.
for me late. I'm back, but this is can you show me the first page? Like there's different conditions you can set.
Yeah, to filter.
Okay, actually, what is this? Yeah, what is this? Right now the topic name is what? Again, I can explain it. Don't worry. The topic name is what? Conditional route advertisement, right?
Okay.
So what happened in this conditional route advertisement? Here we are making a condition. How? Okay, I'm saying to this customer edge router. Right now, what happening actually? This Juniper router having 100 route. Palo Alto Networks having a 200 route, and this router having this 10.0 network here. Okay, so this router will share 10.0 network here. Okay, on these routers, and these Juniper and Palo Alto networks share this 100.100 and 200.200 prefix to here. Correct? It means what happening right now? Right now, this customer edge router will out 10.0 route. Okay, and customer edge router will in this 100.100.100 and 200.200.200. Correct? So this is what?
Flow
Of the packet. Correct? This thing is clear to you, Hector?
Yes.
Okay. Now using the conditional route advertisement, we are making a condition here. How? Okay. I make a condition what? When this customer edge router will receive 100.100.100 and 200.200.200 route, then only you can share out the 10.0 network towards ISP. If this customer edge not receiving this 100 or 200 route, then don't share this prefix to, like, don't share this 10.0 prefix to ISP. Clear?
Okay.
Hector, this is clear for you?
Yeah, exactly.
Yeah, actually what happening? I'm making a condition here. When I receive 100 or 200, then only this router will share 10.0 prefix towards ISP. Okay. If I'm not receiving those route, then this customer edge router is not sharing 10.0 route towards ISP. Correct? Okay. Now, what are the configuration? These are the configuration. Okay, I'll show you. So first of all, what I can do? First of all, I'll create a ACL here. Okay. Then the permit statement, two permit statement, that is 100.100.100 and then what? 200 or 200 or 200. Correct? Okay. Okay. It means here I'm saying what? Here I'm saying what? Whenever 100 dot 100 dot 100 dot 100 and 200 dot 200 dot 200 dot 200 route is available inside the routing table of customer edge router, then only this customer edge router will advertise out this 10.0 network. Okay. So here what I'm saying, I'm creating a 2 ACL. That is what permit statement, and that is what 100 and 100, and then what 200 or 200, 200. After that, I'll make a ACL here, route map exist permit. The name is what ACL, that is exist. Okay. And inside the exist, what I'm saying, match IP address 10. It means inside this route map, that route map name is what exist. Inside this route map, these 2 ACLs are available. Correct? This thing is clear?
Okay.
Yeah, that's the permit.
Okay. Now again, what I can.
No, go ahead. Go ahead.
Okay. Now again, I'll create one more ACL. Okay. And in this time, inside the ACL, I'm saying what 192.160 10.0, right? So here I'm saying what 10.0, and again I'll create a route map. That route map name is what advertisement permit, and inside the route map I'm matching this ACL. Correct? It means very simple. I'll create 2 ACL. These 2 ACL I can add in this route map. I'll create one more ACL here, and I can add this ACL inside this route map. Clear?
Yeah.
Hector, this is clear for you?
Okay, yeah.
Okay. Now,
So a question, the
so
name exists.
very simple.
You just the name, the route map, the name exists. That's just a random name you chose to put, right? It
Exactly.
doesn't have
Yeah,
to be
you
exist.
can choose any name,
Okay.
no problem.
Exactly. Can be anything.
You can name a yeah. You can name
Okay.
any name. You can use any name, no problem. Okay. Now, so it means what happened? Here we have a route map. That name is what exist. Inside the exist, 100 route is available, and 200 or 200 or 200 2 route available, right? And again we have one more ACL, that is what advertisement. Inside this advertisement, we have an ACL that is 10.0, correct? Right?
Okay.
Okay. Now what I can do, I'm saying what router BGP 4000, and then say what neighbor 99.99.99.2, and then say what here I'm using 2 keyword, advertise map, and then what exist map.
Okay.
It means here what I'm telling you, if this route map are exist, it means exist is what exist ACL I'm adding here, right? It means these 2 routes are exist in the routing table, or we can say these 2 routes are available in the routing table. Then what you can do, then you can advertise map, then you can do advertise 10.0 prefix to out.
Okay. Got it.
Okay, are you understand the commands? Yes. Yep. That's it. So now if I'll show you here, so can you see here, I'll show the customer edge router. Can you see here, do show IP?
No, I did see all that when I came. So when I came, you were showing Juan Manuel all that.
Can I explain again?
No, that's okay. You don't have to explain again. I watch all what you're saying. I was watching. I understood. Now I understood. Now it makes more sense.
Okay. Now what happening? Now I'll show you in customer edge device. Can you see here, do show IP BGP? I can receive 100 or 200 route or not? Yes. Okay. I can receive right now 100 and 200. Now I make a condition here. What when I receive 100 or 200? So what this router will do? It means this router will share 10.0 prefix to the ISP. Yes or no?
Okay.
Okay, I'll show you on ISP. Do show IP BGP. Say enter. So yes, ISP will receive 10.0 route. Right or wrong? Perfect. Now what I can do? Let's go on the Juniper. Let's go on here, and here. Okay. So first of all, let's go on the Juniper company and then say, know this command. It means using this command, using the network command, what this router will do, this router will share this 100 and 100 prefix, right? Okay. Now I say know this command, and on Palo Alto network as well, I'll say know this command. It means now these Juniper network and Palo Alto network don't share these prefix. It means this customer router not receive 100 and 200, correct? Yes, and if it is not receiving 100 and 200, then this customer edge router is not sharing 10.0 route towards the ISP, right or wrong? Okay.
Exactly.
So I'll do one thing because I'm saying know this command. I'm doing the change on this device. So just to say do clear IP BGP star and then say soft, and same command we need to use on this device, do clear IP BGP star and then say soft, right? Now I'll show you the edge router, edge device, customer edge router here. I'll show you here now. See, previously I can receive 100 and 200, right or wrong? Now again, if I'll show you, do show IP BGP. So I'm not receiving those routes. Which one? 100 and 200, right? And yes, it will be show me here 100 10.0. But this router don't share this route to ISP. I'll show you on ISP now. Do show. See, previously ISP will receive this 10.0 route, correct? Now if I'll show you, do show IP BGP. So ISP is not receiving any 10.0 route from the customer. Clear?
Got it.
Now again, what I can do? Again, let's go on the Juniper device and just to say yes, this command, do clear IP BGP star soft, and then say on Palo Alto network, just to say yes, this command. Okay, and then say do clear IP BGP star soft. They enter. Now let's go on the customer device, customer edge device. Now if I'll check, so yes, I can receive 100 and 200. 200 I'm not receiving. Wait for a second.
What's a question? What is okay, no, never mind.
Yeah. Now yes, 100 and 100 and 200 or 200 I can receive 100 and 200 both. Now immediately this customer edge will share 10.0 prefix to the ISP. Now if I'll show you on ISP, can you see here previously ISP don't receive any 10.0 route. Now if I'll show you do show IP BGP, so yes, it will be receiving the 10.0 route prefix, correct? That's it. So this is called what? Conditional advertisement. It means here we are making a condition. When I receive the route, then only it will be work. If I'm not receiving, then they don't share. Okay, like this.
Okay, let me write that down 1 second.
And one more thing. You can do opposite as well. Okay, you can do opposite as well. How? Okay, right now the condition is what? When I receive 100 and 200, then I say to customer router, please, when I receive this route, when these routes are showing me in the routing table, then please share 10.0 route to the ISP, right? Now I'm changing the condition. What? I'm saying what? Whenever you are receiving 100 or 200 route, so you don't share 10.0 prefix to ISP.
Okay.
Okay. And if you are not receiving those routes, then yes, you are sharing 10.0 prefix to the ISP. It means this is the opposite, right? So how we can achieve that? Okay, now I'll show the command. Just do one thing, do show run. Pipe section router BGP. Remaining all the commands are same. Just to know this command. Okay. Just to know this command, and again use the next command. The neighbor is what? 99.99.99.2, and then say what? Advertise map. What is the name of advertisement? This is the advertisement name, and then say advertisement, and then say what? Previously I'm saying is exist map. Now I'm saying what? Not exist map. It means when the 100 and 200 route is not exist, then advertise the route towards the ISP. And here I'm saying what exist. Say enter that says do clear IPBGP star soft. Right. Now if I'll show you, do show IPBGP. Can you see here? It will be receiving 100 and then what? 200, correct? And I told you now the condition is what? When I receive 100 and 200, then don't share that 10.0 prefix to the ISP. It means ISP router, don't show me the 10.0 prefix. See? Right?
Okay then.
Any doubt? Okay.
Okay.
Now what I can do? Let's go on the Juniper router and then say what? No. And then say do clear. Clear IPBGP star soft. Okay. And then go on the Palo Alto router and then say here what? Know this command. Do clear IPBGP star soft. Now if I'll check the routing, if I'll check the BGP table, so I'm not receiving 100 and I'm not receiving 200. And if I'm not receiving, then it will be share this route, share the 10.0 route to the ISP. Now I'll show you first of all the customer is a router. Do show IP BGP. So now I'm not receiving 100 and 200. Yes, I can receive 200. Wait for a second. Let's check on the Palo Alto networks. Here I'll say yes. Everything is good. Now again, let's check on the customer. Still I'm receiving 200. Yeah, now I'm not receiving, right? Now I'm not receiving 100 and 200 route. And if I'm not receiving, now if I'll show you on the ISP, now this ISP router will show me the 10.0 route. See? Done?
Okay.
This is
Awesome.
opposite.
You can do that also. Okay. Can I check out again the note so I can write it down and also the command?
Yeah, I'll show you the command. Now this command are exactly same like that, like here. Okay. Just I'm changing here what?
Okay.
Just to say here what?
Okay. Non-exist map. Okay.
That's it.
Let me write that down.
This is the change.
These are all? Okay.
It means, again, I can explain you the command. It means when these routes are exist, then advertise the route. Okay. It means when these routes are received on the router, then please share the route to the ISP. And here, when these routes are not exist, when I'm not receiving 100 and 200, then share the 10.0.
Okay.
That's it.
Can I see like the steps? Are these the steps to create the command?
Okay, see. Again, wait. These are the commands.
So first you create the access list, then you create the exist.
Yes. First I'll create access list, then I'll create route map, then again I'll create one more access list, then again I can create one more route map. It means right now we have two route map, and using this neighbor command I can add both the route map. The first is that is advertisement, the second is that is exist. Here also the same, exactly same. First of all, I'll create a two access list, then that access list I'll add on the route map. Then again, I can create one more access list and I can add this access list inside the route map. Then these, we have two route map, then both the route map I can add here. Okay.
Okay.
Yeah. That's it.
Perfect. Okay.
If you want to write the command, so you can do that.
Yes. I'm writing. Okay. Can you go up a little bit higher to grab the whole thing?
What?
That is all? Okay. Isn't it goes like, isn't there more commands up on top?
No, there is no
Okay.
any command now.
Okay. 1 second. Okay.
Yeah.
Okay. I think I'm done.
Once you complete, so please tell me.